Hi everyone, welcome to the Art of the Possible series. I'm Nihali Niyogi and I'm a Principal Cloud Solution Architect at Microsoft focused on advanced networking. Today's topic is HCX MON Mobility Optimized Networking with AVS, inspired by a recent customer engagement. And in this video, we will be sharing real-world scenarios, expert insights, how to build the lab, followed by an end-to-end demo later. We envision this series to be a multi-part series, and we would be adding future videos on AVS v2, NVA designs, and other networking-related topics. Before that, though, I would like to go through a round of introductions. And again, I'm Nihali Niyogi. I'm based out of Boston, and my background is in data center networking and security. Prior to joining Microsoft, I worked at a cloud service provider where we ran a VMware vCloud director-based public cloud. And we had implemented NSX back then. And in fact, that's where I met Victor. And Victor, it was really cool to get the ninja training done together, good old days of ninja training. And again, it's a small world today. So Victor and I work for the same company, Microsoft. With that, I would like to welcome my guest, Victor Sandoval, who is an NSX guru. And personally, Victor, I have learned a lot from you. I truly admire your passion for networking. And we also have Jeff Moore, a triple CCIE and a networking expert from VMware. It is an honor to have you both on the show. With that, Victor, I will let you introduce yourself.
Thank you, Nihali, and thank you, everybody. Yeah, so my name is Victor Sandoval, and I am also a principal solutions architect working at Microsoft. My background is cloud computing, networking, and prior to joining Microsoft, I spent 13 years at VMware working on all things related to cloud and networking. Yeah, so kind of similar backgrounds, Nihali, you and I. And also with us is Jeff. Jeff, do you want to go ahead and introduce yourself?
Thank you, Victor. Yes, my name is Jeffrey Moore. I am also a solutions architect focused on Azure VMware Solution, and I'm based in Europe. And I've worked with Victor in the past and also co-presented with Nihali on this topic.
Excellent. Thank you both. Pleasure to have you both on the session. With that, let's get started. In this video, we will be building the HCX MON Lab. This lab is based on AVS V1 architecture, but we expect the MON components to stay the same. We will be sharing future videos on V2 architecture, so please stay tuned for that one as well. So this video is kind of unique in a way that it was recorded from the whiteboard stage, and it's based off of a lab that Victor and I built to mimic a customer scenario, and we thought we would share the learnings more broadly. So you'll see this whiteboard diagram in the video. However, by the time we release this video, we will have the draw IO. So you'll see the whiteboard architecture in some parts of the video. And at a high level, the design is the blue boxes are Azure, the green box on the left is Simulated On-Prem, and the yellow box is AVS. Of course, the real on-prem would look something like this. What you see over here would look something like this. It does not require NSX, but HCX does require on-prem to have the DVS, the distributed virtual switch. With that, let's jump on the draw IO. If you've been following along with us, this architecture would look very familiar to you. The top box being Azure hub-spoke architecture. The blue box on the right is AVS, and the yellow box is Simulated On-Prem, but behind the scenes, it is another SDDC. Again, take a note of the region. The top region is East West, and we have provisioned the 2 SDDCs in Australia Southeast. So first, let's look at the use case. Why HCX MON? So the 2 primary use case for HCX MON is to extend on-premises networks to AVS. HCX MON allows the migrated VMs to retain the original IP. by extending layer 2 networks into AVS. And it's also used for seamless VM mobility. You can move VMs between on-premises and AVS. So with that, we will be going into a deep dive use case discussion with Jeff in the future in part 2 of this video. But for now, this is the lab architecture. So let's connect these to AVS environments so that we can access them. Notice that there is a VM over here which we will be using as a jump box. And notice all of these IPs over here throughout this session. This will come in handy. So this is the jump box 172.16.1.5. And what we will do is we'll connect AVS to the Azure VNet so we can access the vCenter through the jump box. So for that, we will build the express route connectivity. Then we'll build a workload segment in AVS, and let's look at the few flows. So the blue flow is from this VM, we'll be accessing vCenter, and then we will also test other flows like VM in AVS talking to VM in Azure, the orange flow, and then the green flow, which is internet bound flow. And likewise on the other SDDC, the simulated on-prem SDDC, we will test all of the flows. We'll access vCenter over this express route connection. We'll egress from this on-prem, and then we will also connect to Azure VM. So these are the different flows. What we will do next is we will connect these to SDDC. In a real scenario, in a real on-prem, we would be using global reach because in this scenario, even ER to ER is not possible because this is a hub and spoke architecture. Either you could use vWAN for that or global reach is the preferred method. But because this is a lab scenario and these are both in the same region, we will be using AVS Interconnect. Of course, this is not a scenario that you would have in the real world, but for now, for the lab purposes, we would be using AVS Interconnect given they are both in the same region. And once that interconnect is in place, we would be able to ping these two VMs. Then we will deploy the HCX appliance, and then we will have connectivity between the two sites, and we will deploy all the different HCX services. We will create a segment called web segment for L2 extension. We'll in fact create 3 segments: web, app, and DB. And notice I have the IPs over here, the third octet being 21, 22, and 23. Again, the left side has 10.101 networks, the right side has 10.100 networks. And once the segments are extended, we will test connectivity. So let's hide the app and DB for now. We will test connectivity to Azure. So this VM reaching Azure and this VM reaching Azure. Of course, as you can see, this is the suboptimal flow tromboning back to on-prem to go to Azure. And then we will also look at the internet bound flow. The default gateway of this extended segment is still on-prem, so it will trombone back to on-prem and go to the internet. So these are the different flows that we would be looking at. We will be doing a deep dive on all the different flows, including VM to VM, and then we will also look between the segments, right? So, and Jeff has a fantastic session coming up in part 2 on all the complex scenarios. But for the lab, we will be testing connection, primarily focus on this blue flow from VM in AVS to Azure VM. And then we will also look at the the main problem statement and what MON brings to the table. So when we enable MON at a VM level or the subnet level, and then or the segment level. And when we do that, it advertises the /32 route. And what happens behind the scene is that path gets asymmetric. And this is where the solution with policy routes comes into play. And we will be showing you that later in the video. With that, this completes the lab architecture design. And so the key points to note over here are the regions. So when we show you pings, you can see the latencies. Also note the IP, the simulated on-prem is 10.101 networks, and the AVS is 10.100 networks. And for completeness, I have also put the vCenter and NSX Manager FQ URLs over here. So when you're following along with us, you know where you are in the which vCenter you are connected to on-prem versus the AVS side. With that, keep in mind that we are using AVS Interconnect. So sometimes you will see the behavior is slightly different than a real on-prem. The behavior of the way that you will see effective routes on that VM, you will see 4 entries, but that's because we are using the AVS Interconnect. In the real world, you will not see those. With that, let's dive right in. We will start with building this yellow SDDC from scratch and work our way through building the entire and HCX MON lab. So let's do this, Victor. Let's start at the beginning, like search for the AVS thing, and then we'll go from there.
Okay.
And then.
So we'll make sure that we're in the right subscription. Then we search for AVS.
Right.
We're going to create a new one.
Yep.
A new SDDC. I'm going to create a new resource group.
And we want to do it in Australia Southeast, right?
Yeah.
Okay.
We can make it in another region, but we just want it closer so that we don't have that much latency.
Mm-hmm.
Then we're going to do 3, the minimum number of hosts. We're not going to do stretch clusters. We don't need to do that. You know what stretch clusters? You know what stretch clusters?
Victor, let's let's talk a little bit about stretched clusters, just for the benefit of our audience.
Okay, so there's 2 types of clusters available to you on AVS. One of them is just all your hosts are in one availability zone. And basically that gives you 3 nines availability, so 99.9% uptime. If you have applications that require to have higher availability, like 99.99, 4 nines, then you go into spread the clusters across 2 availability zones. There's a couple of things that you got to take into consideration with hosts in 2 availability zones. VMware calls this stretch clustering. Basically, you need to have the same amount of hosts in two AZs. So the minimum entry is 6 hosts, 3 in one AZ and 3 in the other AZ. And the storage is synchronous, meaning that any write that you do in zone in one SDDC is going to be automatically and synchronously replicated over to the secondary site. So in case the one availability zone goes down, you don't lose any data. It's since the storage is synchronous, you just lose a small ping while the virtual machine is being rebooted over into the secondary site. This is a high availability solution. It is not a DR solution, so just keep that in mind, and the cost doubles. So that extra 9 means 2x the price. And because it requires exactly, it requires to double the capacity from a storage and compute perspective.
Yeah, got it. Thanks, Victor.
So in this case, we're just going to do 3. And then this is the address block um, that we need to deploy. So it asks for a /22. And we had to make sure that it does not overlap with any of your existing IP spaces, either on the cloud or on premises, because we're gonna be connecting them, and you don't want to have IP conflicts. This /22 is gonna get subnetted out, so you're not gonna be using all those IPs. But the reason why we require the /22 is because it gets subnetted out, and we are expecting the solution to grow not only in the number of hosts, but in the number of features that VMware can release in the future. So Nahali, I believe your environment was 10.x, right?
Yes, so mine, so maybe we should do it in a way that it doesn't conflict with mine for our long-term plan. But I also wanted to talk a little bit about that /22.
Yeah.
Because it is, a question that I get a lot from the customer. So this is more for all the vMotion and the control plane IPs. This does not include the workload subnets, right? So when
Correct.
people spin up VMs, right? Yeah. So just wanted to call that out. And we'll share the link to the best practices for choosing this range as well. So I'll put a link in the description for that. So here, yes, mine, let me give you mine. And we can make something different for yours. So mine is 10.100, 0022. So maybe we make yours 10.101.
Creator. Okay, now we wait 3 hours.
I have a plan for you, my friend. So if you're following along with us, in this video, we're going to show you the Azure VMware Solution. So let's take a look at our starting point. We typically start with a hub and spoke architecture in Azure, the top blue box. And we have two connections, one to a site-to-site connected branch and another one to an express route connected branch. So this is a hybrid cloud architecture. Most of the time, we see this as a starting point for our hybrid customers. So now let's bring AVS to the mix. So when you deploy AVS, this is the blue box. It's not yet connected to Azure. So we will jump between the portal and the Draw IO to show you exactly how to connect this AVS to Azure. All right. And I also have optional IP layer. My AVS is deployed using 10.100 00/22. And as you saw in Victor's demo, he picked 10.101. Okay, so this is the deployment, and again, this is for control plane management networks, and we'll give our workload segments from the third octet being 11, 12, and should be 13. And so this is very important to plan out your IPs. Like Victor mentioned, they should not conflict with any of your existing IPs. So this is an optional layer should you have to have that discussion prior with your customer. So now let's jump back in the portal. I already have an SDDC deployed, and we showed you how to do it from scratch as well. So let's make some observations over here on the overview screen. As this was the block that we gave, the /22, and you can see that it has been sliced into different blocks for vMotion management, etc. Okay. And then the most important screen from a network connectivity standpoint is the network connectivity that allows you to connect to Azure. We will be using this Express Route tab to get connected to Azure VNet. And then there is also workload networking. we will talk about that as well, where you can define how you want the workloads to egress out of AVS. Okay, and this is the default. We'll start with default and we'll work our way through other options. Okay, anything, Victor, you want to call out for just the network bits here before we start to kind of connect to our cluster?
No, I think you covered the basics. I think the next step here is to connect to an express route to an existing VNet so that we can control the vCenter. So I believe Nehali, you have a virtual desktop already up and running.
Yes, I do have a VM. That's actually a good point. I have a VM, a Windows VM running here. So once we connect this through the express route, we will be able to get route to the vCenter. Okay, but I don't have an express route gateway. It may take a little while, but let's go ahead and kick off that install as well. So here we are. Let's go see. We'll just go ahead and kick off the gateway. And we'll call this ER Gateway Hub V East. We'll put it in East US 2. We'll attach it to my Hub VNet East. Oh, I have to pick the Express Route Gateway. I already have a VPN gateway. And yeah, so let's go ahead and kick off this install. What we will need is we will need a key that we can redeem on the other end. So we'll just call this Hub VNet East connection key. I'll just put my initials just in case. This is a shared environment. And we'll need all of this information when once our express route circuit, express route gateway is up. We'll need that information. So we'll go ahead and save that. Not sure if it save button is grayed out here. Let's see. Let me move away from it. Okay, so we still have the key, and we will wait for our gateway to be provisioned. Let me jump back in here. This does take a 15-20 minutes, so we'll wait here. We'll pause the video here. So we now have the ER gateway deployed. It took a little bit. It took about 22 minutes or something, and we had paused the video. So next, what we will do is we'll go ahead and connect our AVS environment to Azure. And again, this is a V1, AVS V1 design. In the future videos, we'll talk about AVS V2 and how that gets connected. So again, back to the drawing board. So far, we have just created this AVS environment, and we have created the ER gateway. Next, we will be connecting the circuit and creating a connection. Okay, so going back to the portal. And for completeness, let's look at the VM which we will be using as a jump box in Azure. That VM is in a VNet, and just let's look at the effective routes of that VM before we connect. So right now we don't see any of the AVS network propagated over here. Okay, so again, my VM is in the subnet. It's in the management subnet, and in this subnet 172.16.1, look at the IP address of the VM. It has the IP address of 1.5. Okay, so let me grab, so let's go on the express route gateway itself, and we will create the connection. So we'll go to connection and we'll say add. So here, We'll keep this in the management resource group. We'll call it Express Route. And for now, we will just put the standard resiliency for the express route. We will pick the gateway, and then we will over here the key configuration is that we will say redeem key, and we will grab the key from the SDDC side. So we'll go on the SDDC side. If you remember earlier, we created the key, so let's grab that key. So we'll grab the key, and then we'll get the peer circuit URI, which is also over here. And oops, I think I picked the wrong thing.
Well, that happens to me at least twice.
Yes, so let's go and put the right. Okay. And it's smart enough to give you the error, and we will say connection to hub VNet East. Okay, so that's what this is. And then we'll go ahead next and review and create. Any other comments here? Anything you want to call out, Victor, before we hit create?
No, so just wanted to recap. When you first deploy AVS, it's completely isolated from the rest of your infrastructure. So it's not connected in any way to a VNet or to on-premises. And the reason why we're using the express route connection between this vHub is to basically just provide that connectivity. And what this is going to do in the back end is that it does a BGP peer between the NSX tier 0 over to that express route. So any routes that you are going to be advertised in and out of the environment is going to be through BGP and that express route circuit.
Yep. Yeah, and that's exactly the reason we did this before capture, so that we can then compare the routes after. Good point. Yep. So let's go ahead and hit create. And this may take a few minutes. So while that's happening, we're going to jump back into the Draw.io and complete our envisioning. So like Victor mentioned, just created this connection, and then we have a VM in Azure. So what we will do next is we will jump onto this VM and we will access NSX Manager and vCenter. So that would be the first flow of interest. And then we will create a few segments. We will connect a VM to the segment, and then we will look at a few other flows. We will look at the flow between Azure and AVS, a VM in AVS. We will look at flows from a VM in AVS to the internet using the default outbound. So if you remember, there were 3 different ways that you can egress. We will start with the default method. And then the last flow is inbound into AVS. There are several different ways to do it. We've done deep dive videos on other ways to do it, but for simplicity here, we will drop an app gateway, and then we'll put this VM in the backend pool. So that's just all the flows that we will be testing at the end of this exercise. But I do want to call out 2 very important constructs, and no other than I guess Victor to talk about these 2 NSX construct, tier 0 and tier 1. If you want to add some extra commentary here, Victor, on the roles that tier 0 and tier 1 play from an NSX perspective.
Yeah, so the tier 0 really is the gateway between the physical and the virtual space, and in this case, the physical space being the Azure infrastructure, even though it's all overlay. But southbound of the tier 0 is really the NSX overlay. And typically, what happens when you deploy AVS is that the tier 0 is automatically deployed on your behalf. And the management that you have from that tier 0 is very minimal. Microsoft handles most of the management for that tier 0 because of obvious SLA reasons. So for example, you cannot delete that tier 0, you cannot disconnect it from its top of rack switch, because then you won't be able to get into your environment. So that's why there's zero management on that tier 0. What most customers do in their day-to-day operations is done on the tier 1. Now, when you deploy AVS, you'll notice that there's a tier 1 that's automatically deployed on your behalf. Some customers choose to delete this tier 1 and start a new one, but most of them just leave the current tier 1 as is, and then they can deploy multiple tier 1s as they see fit. And there's all kinds of architectural reasons on why you want to have multiple tier 1s. So one of them can be exposure to the internet. Maybe you want to bring a public IP address to a specific tier 1 and make that like a DMZ zone inside of a NSX. You can have another tier 1 be isolated, so basically not connected to the internet. For X amount of reasons, disaster recovery, a sandbox environment, yeah, you name it. So really, most of your architecture that you're going to be doing inside from an NSX standpoint is southbound of that tier 0. So,
Got it.
Yep.
And also, like, this tier 1 is like a multi-service router, if you will, right? It does firewalling, netting, routing, DHCP, DNS, all of those functionality, right?
Absolutely, yeah. So you can do that as well. Although most customers, they typically do distributed firewall if they're going to do the firewalling capabilities. But netting, DNS, and DHCP are probably the most common use cases for that tier 1 outside of just basic routing.
Yep. And one question, I just thought of this flow, that the first flow that we do that's from the jump box VM to vCenter, does that traverse both the tier 0 and the tier 1, or does it just traverse the tier 0?
Yeah, so actually we don't really document that, but yeah, there's actually a connection between that VM, that's the vCenter, and there is a backway connectivity, but for management purposes, we don't display that because the customer doesn't have a way to make changes on how that connectivity happens.
Yeah, so I just wanted to make sure that this flow is a little bit abstracted, but the idea, what I was showing was that we'll jump on this VM and access this control plane, NSX Manager and vCenter. So let's go back and see if our connection went through. Any other comments before we move, though?
No. I think we can keep going. If I think of something, I'll bring it up.
Okay, all right. Yeah. So in addition to what Victor mentioned, there is one more construct in NSX called the layer 2 segment, or often referred to as NSX segment. Think of it like a layer 2 switch with ports. So in other words, the VMs will connect into the ports in the switch. Just like that, you would connect the NIC of the VMs to the layer 2 segment. So with that, let's go on to the next section. So it looks like our deployment of the connection did go through. So let's go ahead and let's go to the resource and just validate that it indeed went through. So I will jump on my ExpressRoute gateway and let's take a quick look at the connections. That should look healthy and succeeded. It indeed does. So now let's go look at the effective routes here on the VM. And as you can see, all of the AVS routes got propagated over here. And like Victor mentioned before, these are all more specific routes. If you have any additional comments on what we are seeing for these routes, Victor?
Yeah. So what effectively happened is that the automation for deploying AVS grabbed the /22 that we awarded during that we allocated during the wizard process, and that got subnetted it out for all the other components that VMware needs for management. So for those of you that have deployed VMware environments from scratch, this is your VM kernel networks for vMotion, for vSphere replication, for management, for the NSX overlay that is used in the backend to deploy NSX, and etc. So, and also one thing that Microsoft has done is that they future built. So whether your environment is 16 hosts or it's going to be hundreds, up to 96 hosts, your IP space requirements is the same. And also, if VMware decides to deploy more products in the future, and these are going to be added into AVS, then that's why we requested for such a large /22 IP space, so we can have room to grow.
Excellent. Yeah, and that's a question that comes up very often in the discussion. So just wanted to make an observation here about, if you, in addition to what Victor said, if you notice the third octet over here, 0, 1, 2, and 3. And so if you're using this draw.io, again, you can download this from my GitHub repo. I've put an optional IP layer over here, so kind of facilitates your discussions with the customer. But this /22, if you notice, is broken down here 0 to 3. And of course, the third octet I'm talking about. And this does not include the workload segments, right, Victor? So if you, once you start provisioning the workload, you can pick something after 0 through 3 for the third octet. In this case, I have picked 11 as a third octet, but and that's a very important call out, that /22 does not include workload segments, and it doesn't have to be contiguous. In other words, when the workload segments, you can pick on 72 to 16, for example. But the idea is you want to continue on that same 10-100 track if possible, if there's no conflict.
Yeah, no, that's exactly right. So it just becomes on how you're gonna allocate your IP space inside of AVS. So like you mentioned, Holly, the /22 is purely for management purposes. You cannot use those for any virtual machines that are going to be used for workloads. So like you have in this drawing, one thing that I always get customers ask me is, if I deploy this segment, which is 10.100.11.0, how is that going to get advertised? Well, the tier 1 automatically advertises everything to the tier 0. And that's done through VMware proprietary control plane. It's not OSPF, it's not BGP, it's just automatically done when a tier 1 connects to a tier 0. So if any segment that you get created, the tier 0 is going to advertise it via BGP to the outside world. So your Azure routes should pick it up. If you want to block that from happening, you can go to the tier 1 where that segment is created, and you can say, do not advertise this specific network. If for some reason you want to isolate it from the rest of the Azure infrastructure. And we can do that. I can show you how to do that as we progress.
Great. Yeah, that would be great. And I think that it's by the virtue of this being a connected segment,
Correct.
Right?
That's exactly right. Yeah.
Perfect. So let's go ahead and jump on to our, so we'll RDP into this jump box, and we will get to the vCenter. So before we go to the jump box, let's go ahead and grab the URL for the vCenter. And for that, you need to go into the SDDC VMware credentials. So notice that at the top you have vCenter, bottom here you have the NSX Manager. So we'll grab first the username and password for vCenter.
I think it's just important to note that for those of you that are new to AVS or any managed VMware solution, the reason why you don't have access to administrator at vSphere.local, which is typically the root account for managing VMware environments, is that AVS is a managed service, right? So your cloud admin account is basically the permissions that you have access to meet the SLA requirements of AVS, which is 99.9.
Great point. Thanks, Victor. Yeah, and if you are curious, what is this resolving to, which I was earlier when I saw that the first time, and it does indeed resolve to that 10.100.02 IP, and likewise the private IP, so it's going over the express route connection and 02 and 03. So far so good. We now have access to our vCenter, and what we'll do is we'll go ahead and kick off the upload of an OVA file that I have downloaded. So I've downloaded this little photon OVA, and so we'll go ahead and upload this to our data store. I'm getting rusty here, so I'm happy that I have you.
Oh yeah, no problem.
Victor.
Where did you put it? Yeah, go to the data
So
store
it's
tab.
locally, yeah, it's locally on my jump box. So we just have to kick off the upload, and I also have, for future videos, I also downloaded the Ubuntu. So when we get to the NVA, we have that ready. But for now, for this session, we just need to upload this one.
Okay, yeah. Well, typically what you want to do is create a content library, but we'll keep it simple at this point in time around. If you can click on data stores, there you go. Then you'll see the vCenter data store. And then go to files, which is next to permissions and configure. Then just create a folder. And this is call it OVA.
Or images, maybe.
Images, there you go. And again, ideally, we wouldn't want to do something like this. We just typically create a content library where we have all of our templates and ISO files, but this is just a demonstration. So just click on that images, and you should see an upload file.
This one. Yeah, so this may take a few seconds. So while that happens, we'll do a quick overview here, if that's okay, of the vCenter and the bits that are most important. And again, this is more geared towards Azure architects in the field, kind of wanting to understand the other side of the house, right? So it's not supposed to be a deep dive, but just kind of give an overview of this.
Sure. So if you click on the first tab, which is the clusters view, this is basically your overall view of the VMware environment. An SDDC or a data center gets created, and data center is just a logical representation that VMware uses to basically put clusters in a group. And in this case, it's called SDDC data center. That's done on your behalf. And that SDDC data center has a cluster, and that's where your hosts are going to reside. Now, on premises, VMware admins typically have DRS configurations that they do. For example, what kind of HA settings am I going to set up? Is DRS going to be in fully automatic mode or etc.? In this case, for AVS, it's all handled on your behalf. DRS is automatically configured and HA is automatically configured. And also a resource group gets automatically created, which is the management resource group. So if you can expand on that management resource group, Nihali, here you'll see some VMs that are already deployed on your behalf. And these are NSX virtual machines. So for example, the control planes are in here, the external gateways are in here, and the vCenter is in here. Later on, as we deploy HCX, the wizards are going to automatically deploy all the HCX virtual machines on top of this management resource group. So you can see these virtual machines, but you cannot delete them. You cannot power them off. So like if you right click on this virtual machine, Nihali, real quick on vCenter, and you click on power, you see that you don't have the option to power it off. Even though you're logged in as a cloud administrator of vSphere.local, this particular user account doesn't have permissions to pretty much make any changes to the management resource pool, because again, you will basically black hole yourself out of your environment. And obviously we don't want our customers to do that. And since this is a managed solution, you basically have admin rights outside of that management resource group. Okay.
Got it. Yep.
We already talked about the data store, but let's go to the data store tab real quick before we.
One more question here, Victor. So this resource pool, is it needed for us to create more resource pool to put the VMs in, or how does that work?
So best practices from VMware is always to create more resource pools. If you're going to be using resource pools, all virtual machines should be on resource pools, just so that the virtual machines are not contending resources. So in this case, I will recommend that you create a resource pool for your virtual machines outside of this one. So like, for example, if you right click on an empty space, you should be able to see to create a resource pool, or right click, go to that cluster.
Oh yeah.
Yeah, right click on that cluster and then new resource pool. So we can do that right now, and we can call this production. And not to go into too much into detail on how VMware works, this is how you can allocate shares for CPU and memory. And shares are just a way to prioritize workloads in case that there is a compute contention. Since we're not going to get into this type of detail on this video, we can just leave it and just call it production resource pool and hit OK. And then once our OVA finishes uploading, we can deploy our virtual machine, and it will be part of that production resource pool.
Got it. So should we, let's finish this and then we'll go check if our OVA is uploaded. Looks like it is, as far as I can tell. No.
I think it is, but we still have some work to do because we still have to deploy like an NSX segment, because right now there's no real segment for our virtual machine to be sitting on. So we need
we need to go through that workflow as well. Yeah, so we'll finish these two. So we did go through the vSAN a little bit.
Yeah. So AVS comes built in with vSAN by default. So as you add more hosts to the cluster, your vSAN capacity is going to increase because vSAN is a distributed storage platform. There's also other third-party options for expanding storage. So for example, you can use Azure NetApp files to basically plumb that storage into AVS, and AVS will see that in here. So if you decide to configure that, you can use NetApp to expand the storage. You can also use Elastic SAN by Microsoft to give you more options to expanding your storage capacity without the need to procure additional storage. And there's all kinds of storage conversations and sizings, but for right now, we're just going to keep it at a very high level. If you go back to the virtual machine tab real quick, Nihali, this is basically where you are going to assign your virtual machines from a folder structure. And typically what we tell customers that you want to put your virtual machines in folders. This makes it easier to manage. So not only from an operating system perspective, but also from a disaster recovery. So that way, when you, in case that you fail over to another site, you can map virtual machines from source to target based on folder structures. So in this case, we can just create a new folder, and you can just call it whatever you want, Holly or production. Yep. All right. And lastly, the networking tab. The networking tab is very easy here on AVS. You don't use it. On premises, most customers don't have. On premises, most of the customers don't have NSX, but they do have a distributed virtual switch, or they have a virtual standard switch, and this is where you will manage those DVSs and virtual standard switches. While you do have a DVS here, it's not. You don't manage it from the vSphere environment. You manage it from the NSX environment, and that's where we're going to go next and deploy a network segment on NSX. And we're going to see how the NSX segment is going to get propagated to this vSphere networking tab that Nihali currently has open. So
Perfect.
yeah.
So it's a quick question. I just wanted to call out that there are two distinct workflows for creating NSX. So, well, NSX segments, right? So we also expose parts of it here under workload networking. So like Victor mentioned, before we do anything, we need a segment, right? So kind of coming back to the whiteboard for the workload segment, to plug in the VM, we need to first create the segment. So that's what we're going to do. And that can be done over here, or like Victor mentioned, we could go directly into NSX. Is there, I believe the recommended way is doing it in the portal. Is that right?
I think it's more of a school of thought.
Okay.
So if you want to go more into detail,
Mhm.
how to deploy the segment,
Mhm.
I will go into the NSX portal. That gives you the
Mhm.
most granularity.
Mhm.
But if you basically just want to deploy a segment and put a virtual machine on it, the Azure portal is probably the easiest way of doing it. How about this? How about we do it both ways?
Yeah,
That way,
let's do it both ways, because I think that this workload networking kind of has its flow. So you need a segment, you need DHCP and DNS for all of it to work correctly. So maybe we just walk through this, and then the next segment, we will do it from NSX side.
Sure. So from right here, let's go ahead and click the add button.
Yeah. And we'll set it up for our future videos. So we'll call this red segment because we want to kind of eventually do red, kind of have multiple red, green, blue segments and show some isolation in the future as well. So we'll kind of call this red segment for now. And here is the gateway. So we planned to have, let's see, what did we plan to have for our segment? 10.111.
So this is going to be a virtual interface that gets attached to that tier one. And one thing I want to point out, one of the main differences, do you see that connected gateway? It says T1, TNT 57-T1. That's the default tier one that was deployed as part of the deployment process for AVS. Let's say that day two in operations, you want to deploy another tier one for isolation purposes, or X, maybe you want to use it for DR, or you want to just expose a public IP to that second tier one. You see how there's no drop down menu on this wizard? This wizard is only going to deploy segments on that T1, on the default T1. It doesn't see secondary tier ones.
Good point. I didn't know that. So in the future, when we can validate that as well. So it would, even if we deploy another T1, it wouldn't show up on this workflow.
Yeah, we can try it if you want later. We can deploy another tier one, and we can come back to this wizard. And if I'm not
Yes.
mistaken, you'll see that there's
Yeah,
not going
we'll
to be a
remember
drop-down
to
menu.
do that when we do our NVA video. We will definitely need some scenarios. We will definitely need the second tier one. Okay, yeah, that's a good point. So this one, sometimes, it's often confusing for our customers. So just want to highlight that this .1 is gets assigned to this tier one, and then the VMs will get IPs from this segment, this /24.
Yeah, and just to point out that a tier one can have up to 1,000 interfaces, so you can connect up to 1,000 segments to a single tier one. If you need more than 1,000, I doubt you'll need that, but if you need more, then you can deploy another tier one.
Good to know. So it looks like this one's optional, so we'll skip it for now until we hit the DHCP part.
Absolutely, let's do that.
Okay. You just reminded me of one thing. Should we just capture, just for the completeness of the video, should we capture what the current inventory looks like before and after kind of thing? So this is our tier 0 gateway. So here I am on the NSX networking tab. So that's the tier 0. Then we have tier 1. And
Yeah,
we'll go into deep.
or better
Sorry,
yet,
go ahead.
click on that network topology tab
Ooh, where is that? Oh, yeah.
on the second one.
Nice.
Yeah.
Oh, okay.
I know you like drawings.
You know me well.
All right, so there's the tier 1.
Oh, yes. Yes,
And
I
then
do like the drawings.
yeah, and then there's a point-to-point network between the tier 0 and the tier 1. That's where the traffic is flowing through in the control plane that we discussed. And then that on southbound of that tier 1.
Just 1 second. I'm trying to move southbound
Just
using my mouse wheel, and maybe
no,
I just did something.
click and hold down. Yeah, just click and drag it.
Okay.
There you
All
go.
right. Thank you. Okay. Perfect.
Yeah, and then you'll see the logical switches, private 01 and private 02. Have you deployed logical switches, or is this part of the automatic deployment?
This is part of the automatic one. So there's 10103. So these are all the, so I don't have,
Yeah.
so logical switches, just from a terminology perspective, is the same as the segments, right? LS.
As a segments, yeah, or some people will consider them the same as a VLAN or a VNet. Right? It's just it's basically a layer 2 network.
Yeah, so LS is the logical switch. So I believe, coming back to your topology, yeah, this is the default topology, Victor. We haven't deployed anything yet. That's why I wanted to grab this.
And I wanted to show you, like, you see the HCX uplink. Once we deploy HCX, and for those of you that don't know, HCX is the components that help you migrate virtual machines from one VMware environment to another. That's where the interfaces are going to be deployed for those virtual machines on the HCX uplink.
Good to know. So it's good that we got the before picture.
Yep. So then go ahead and hit the submit button on the Azure portal.
Yeah, and we'll just grab, there's no segment, so we expect the red segment to show up over here at the end of this exercise, right? So we'll go ahead and hit.
Okay.
On the other side.
Yeah. So what's happening in the background is that the Azure portal is sending an API call to the NSX Manager to create this segment for us. And then you see the red segment is connected to that TNT57T1, and it has the IP space that we provided, 10.100.11.1/24. We didn't configure DHCP for this particular segment. And if we go to our network topology,
where is the DHCP setting here? I am missing it.
Additional settings.
Okay, address pool not set. Yep.
Yeah.
And Victor, quick question over here. Is there a way to see this 11.1 on the tier 1 side?
On the go to the tier 1. And then go to, you're making me go down memory lane. Link segments. Yeah, number 2. So you'll see the segments that are connected to this tier 1.
Okay. And this is the interface IP on the tier 1.
Correct.
Okay, got it. Perfect. Thank you.
Yeah. Now, if you go to that network topology, we should see our drawing be updated, and now we should see 2 segments. There's the red segment.
Very nice.
Yeah,
awesome.
If you click on that line, you'll see sort of a packet walkthrough.
Which line?
Click on the second. There you go. See, it makes it pretty.
All right. Yes, nice. Good stuff. Thanks, Victor. Thanks for showing me this. Yeah, it's evolved since the last time I looked at it, so it's been a while. And so you are right about the memory lane.
Yeah. So now, if you want to go into the Azure side, we should see our routing table be updated with this 11.1/24 subnet.
Point. Yeah, good point. Yeah, let's do that. All right. So we'll refresh the route here. Yeah, there we go.
All right. Then let's nerd out a little bit before we continue.
Totally.
Let's go to the Azure side. Sorry, to the NSX side.
Sure.
And let's go. Yeah. Let's go to that tier 1 gateway. And we're gonna edit the settings here. So if you click on those 3 dots, yeah, and then hit edit. Go to route advertisement.
Oh yeah.
Okay, and here we have, it's automatically going to advertise everything. So it's all static routes, all DNS forwarded routes, basically pretty much anything that we put on this T1 is automatically going to be advertised. So if you put untoggle that all connected segments and servers ports.
Yeah, so this is the connected segment.
Yeah.
I see.
Yeah, and then if we do that, then it's not going to advertise. Don't hit save. But if we do that, it's not going to advertise the network that we have connected, that we just created, which is the red subnet. The problem with doing this is that
all of it.
It's all of it. The HCX uplink network is not going. So your HCX is not going to work. So now you're getting into use cases of why do I need multiple tier 1s? Because maybe you want to block some routes on one tier 1 and keep the other ones normal.
Nice use case. Yeah.
Yeah.
I see. Yeah.
So let's turn it back on because we don't want to break HCX.
Mm-hmm.
And then go where it says set route advertisement rules on the right side. And then add a route advertisement rule. And yeah, and then just, there we go. And then apply the filter and turn it to yes.
Okay.
Yeah, and then hit add. Oh, sorry, advertisement action, block it. Sorry. If you go to advertisement action, deny. Click add.
Apply, you mean?
Add on the, there you go.
Oh.
Yeah, and then hit apply. Then save.
Save.
Then let's go to the Azure routing table. Sounds good. Is it still being advertised?
Yeah. We'll just wait it out a little bit. It stopped. Perfect.
Yeah, go to the go back to the set route advertisement rules. And then on the far left, yeah. And hit delete. Yeah.
Right.
Yeah.
Okay, perfect.
Now let's deploy a subnet the old-fashioned way, right? So
Sure.
if we go to the segments, yeah, that's fine. You can, there you go. And then add a segment. And I think we call it as the blue segment, or.
Yeah, let's call it blue segment.
And you see how we have that drop-down menu for the gateway?
Oh, yes.
Yeah, so we only have one tier 1, so we're going to do that tier 1. And then leave the transport zone alone. We don't mess with this on the cloud because the overlay is already set on our behalf. And let's just configure the subnet. And we're only going to be using IPv4.
Unless you love looking at IPv6 IPs. So here we also give 1/24. So we do give the 4th octet, whatever the IP of the tier 1 is going to be.
Yeah, and you see how we have more settings available to us here. So for example, I can set up tags. So I can say this network is going to be a Windows segment or it's going to be part of the DMZ. I have more granularity. I can also create things like layer 2 VPN. If I want to set up a layer 2 VPN between 2 NSX environments, I can do that here. Or I can set up more segment profiles for security rules. For example, I can do things like app suppression and stuff like that. We're not going to get into those details, but you see there's a lot more things that you can do here if you want to get more granular. But if you just want to deploy a segment and connect it to the default tier 1, the Azure portal is perfectly adequate for that.
So not everything is exposed in the portal, essentially.
Yeah, the way that I
Yeah.
would see it, a network admin will do things through NSX. Just a person who needs to deploy a virtual machine will probably do things to the Azure portal.
Got it. So we'll go ahead and hit save just to see that it shows up on the other side as well. I do want to highlight one thing because this is often confusing to folks that are not familiar with NSX is when it says subnets, kind of giving the precise IP, which is going to land on the tier 1 is not intuitive. So just want to call that out here just to make sure. So if we did put, let's say 254 over here, that 254
Is the gateway.
as would become the gateway, right? Sometimes it becomes more important when we do like NVAs, kind of have that thought clarity about what the default gateway is. We may have to change it, but for now we'll keep it 1 and we'll go ahead and hit save. So blue segment was created successfully. I did observe before, it was a while back, that it does take a few seconds for the segment to show up over here.
Oh, yes, this is true. Yeah, because the API is not constantly pulling information from NSX. So I forget, but it is on a timer. But if the routing table should be updated, and NSX definitely updated this on its topology. So
Oh,
we can.
you saw things
Yeah.
faster than me. So let me just let's just do the one thing at a time. Okay, your eyes saw the topology. So let's first look at the route and then we'll take a quick peek at the topology. Okay, the 12 is here.
Yep.
And kind of going back on the topology, red and blue. Looking very nice. Yeah, looking really nice.
And now, finally, for those VMware admins that don't have experience with NSX or with Azure, if you go to the vSphere portal real quick, Nihali, and you go to the networking tab, expand that DVS, the DVS NSX, the distributed virtual switch on the left side. The left side, yeah, expand it, and then you'll see the blue segment and the red segments. And that's very important because we need to be able to see those so that we can assign our network interface cards on the virtual machines to those particular programs.
Yeah, good point. Yes, so it's now visible almost like a VLAN segment over here.
Exactly. Yep.
Very nice. Yeah, a great call out. Thanks, Victor. So we'll pause the video here and I think we'll pick it up where we expect to see the segment over here.
That's going to take a while.
We now see that the blue segment does now show up here. The blue segment is the one that we created through the NSX Manager, and it does show up over here. It did take some time. So at this point, Victor, I think we're ready to sort of set up the DHCP and DNS bits so that we can then deploy the VM.
Yeah, sure. So if you want to go to the DHCP tab, we can get started. And effectively, there's two ways that you can configure DHCP. You can either do it through the Azure portal, or you can do it through the NSX UI. Just for simplicity purposes, I think we can just use the Azure portal for right now. And there's two settings that you can configure DHCP. One is you can make NSX the DHCP server, in which case here we can just give the name of our DHCP server, give it an IP address, and just configure it from there. But most of our customers, I feel, and I'm curious to hear your thoughts, Nehali, most customers bring their IPAM solutions, typically like an info blocks, and AVS can take that type of architecture. We just use a DHCP relay. So if you click on that DHCP relay,
this one, yeah,
exactly. And your DHCP or your IPAM solution, it can be on premises or it can be on Azure native outside of the AVS environment. And basically what NSX will do is that every time that it picks up a DHCP request, it's going to relay that over to your IPAM solution. And probably about I will say 80 to 90% of our customers use this particular setting. What are your thoughts, Nehali?
Absolutely, yeah. Enterprise customer definitely would use this. And what I've seen, we use DHCP server for quick POCs and demos. We've been using DHCP, but absolutely, that's more common.
Yeah, so I think for the lab purposes, we're not going to do a relay. We'll just do a DHCP server. And just the IP address range on, are we going to use the red subnet or the blue subnet?
I was thinking let's create a new one. So for DHCP, so 10.100. Let's pick something like a 6.0/24. Does it need a 1 here? It does need, right? That's the IP that gets
Yes, it will be acting
on
as the server. Yeah.
on tier 1. Yeah, so we'll put 6. We have 11, 12, and 13, I believe we reserved for, kind of going back to the drawing board. I just need, 11, 12, 13. And we can make the 6 here for, so maybe 10.100.6.0/24 for DHCP. So let's just do that. All right, so here 1, and then
Should we start with the second .2? That way the 1 is the gateway. Or
oh, I see. So this is the server address it's asking for.
Yes,
because
correct.
sometimes on segment, absolutely, no, makes sense.
Yeah.
I didn't realize that was what it was doing. I thought it was asking for the tier 1 IP. Perfect. Yeah, that makes sense.
Okay, and then here we go.
Maybe we should go back in on the NSX server side and also validate what it did.
This should take up a few minutes.
Yep, this one is completed. Okay, so let's go back on the NSX side. So let's look at the DHCP server from the NSX side. So I believe it's under tier 1.
Yes.
DHCP server right here. It indeed got to 6.2.
Yep.
Oops. Showing an error here.
You should be able to click on that error. Oh, okay, it's not being used by any segment yet. Okay,
I
that's
see.
fine.
Okay,
yeah,
that's fine.
We haven't given it a segment. So let's go now to the segments, and I think we were going to use the red or the blue segment for.
Let's start with red. Yeah, because it's the 11 one to match the diagram.
Okay. Right, and then you see where it says set DHCP configuration, and there's a couple of options here. We're going to be using the gateway DHCP server. So in this case, the gateway, the tier 1 is going to act as the DHCP server, and you can tell us right there the address that we assigned it, and we'll go ahead and assign the ranges.
Let's maybe start from 11 to 10.100, 100.11 to 100. So sorry, .10 to 100, right? Is this a good sort of syntax?
I think so. I always tell, I never like to use the first 10 IPs or the first 9 IPs.
Yeah. Talking like a true network engineer. Okay, so and then for the DNS server, we could either use Google or.
Sure, I think for lab purposes, I think it's fine. Or you can use your on-premises. In this case, if we had one, which we don't.
Or what is this new construct here? We could use this DNS service, that IP that's configured over here.
That's also possible. So this is automatically configured when you deploy AVS, and it's forwarding to those public
Cloudflare
DNS services. Yeah.
Yeah. So let's grab this and at least set it up so that when he hands out the IP, it would also hand out the DNS server. Is this good to go?
Yeah, it should be. I just want to point out that most times you probably will set this differently. You will probably use your own DNS services so that your virtual machines have resolution to other servers within your organization.
Yeah, and other custom domains that you have within your
Exactly.
organization. Yep, good point. Yeah, so we'll go ahead and hit apply. Is there a save as well? Yep. Save.
Good. Now I think we're ready to deploy our virtual machine.
Is there anything in the DNS? Okay, so we did already do DNS, so not much to do here. And yeah, let's go and deploy our VM then. So I did show that we uploaded. Let's just go make sure that our image is indeed uploaded. Yeah, I kicked off the Ubuntu as well, but we now have, this is the OVA in question that we would be using.
Yeah, awesome. So if we go to the very left button and go to your production resource pool.
Oh, yes, production resource pool. Yeah.
And right click, and we should be able to deploy an OVA, new deploy OVF template.
Upload. Oh.
Yeah, you can do it from here to your local file, or you can put in the URL.
We did put it in the data store though, right?
Oh, that's right. Yeah, so yeah, I forgot about that. If we're gonna do an OVA, it has to be here. It has to be done through the upload files. Yeah, the OVF, the ISO file is to the local data store. But if you want to deploy a virtual machine through an OVA, it's through your local files.
I see.
It shouldn't take too long. So an OVF is just a virtual machine that's already packaged into a template. So it's very portable. And then the other one will be an ISO image, which is just an ISO for the operating system. And if you're going to create a new virtual machine from scratch, which we don't want to do that in this case. We're just going to deploy the OVA.
Okay. You can put it in the prod VM folder that we created. So it's already pin provisioned. So it says both.
Yeah, but vSAN in the backend is always thin provision.
I see.
Ignore this. Next. And I accept. We only have one option in our lab. We haven't added external storage. And then here we are where we designate the network for our virtual machine. So we hit browse and we should see a red and blue subnets segments.
So okay, and what's this source network?
Yeah, so it's basically if you were to migrate a virtual machine, you have a source and a destination network.
I see.
We don't have this in this case, so you can just put none. The virtual machine is going to land on the red segment once it gets created. Yep, next. And finish.
Yay, so that's our first virtual machines getting deployed there. This may take a few minutes, right?
Yeah, I think we should probably pause the video.
I think we can make some observation here once it's deployed.
Yeah.
So as you can see, the VM is now deployed here. So let's go ahead and start the VM. Okay, so we have the VM console here. Okay, so the Photon VM does come with a default password, which is root and change me. So root is the username and change me is the password. So now we are on the VM. Let's run some validations. So we did get an IP in the 10.111 network. Let's look at the default route. Let's make sure we can ping 11.1, which we can. Let's try to ping something in Azure 1.5. That's our jump host. So we can ping our jump host, and for completeness, let's just make sure that we have the IP of the jump host is 1.5. So it looks like we can ping something in Azure. Let's try to see. Let's see if this has curl. It does. So let's curl dash www.google.com. So this does not appear to be working. Let's wait for it to time out. Okay, so it looks like it's unable to resolve. So let's make sure that we got the right DNS server IP. So system D. We did get 10.100.0.192. So let's verify that was what we did indeed set up for our segment. And that is correct. And just for completeness, that does come from here. So let me bring that up here. And that comes from the DNS setup over here. And that one is set up over here as well. So let's see why this is not working. So our DNS is set up correctly. So let's take a look at the default outbound. All right, so let's go ahead and look at our internet connectivity. That's what it is. This used to be the default setting, so we need to set this up for connect using SNet for AVS to reach out to the internet. This one is expecting default route from Azure, right? So this used to be default, right, Victor?
If memory serves me right, yeah, I
Yeah,
believe so. But so the top one, really, what it is for customers that want to plumb their traffic back to on premises. They can advertise a route, so that way AVS can send that traffic, and that way it egresses to the internet from on premises. And the main reason why some customers want to do this is like customers that are migrating to the cloud, their security stack might be on premises, so they want to do deep packet inspection there, as opposed to doing it on the cloud side, right? So
absolutely. Yeah. And if time permits in the future videos, we'll show other sort of outbound methods as well. And this can also accept route from Azure. So if we have an ARS and NVA combination, in addition to going on-prem, we can also egress from Azure, right?
exactly, that's exactly correct.
Yeah, so we'll go ahead and save. So this may take a few seconds to save. So we will come back and revisit this at that point. We should be able to
Well, we can do a
meet.
continuous ping. That's always fun.
Sure. Yeah, nothing like watching pings working. So let's do that. we just want to make sure that it resolves first. But yeah, so we'll keep that one running. And just for completeness, Victor, so what we did so far is that we accessed the vCenter, we provisioned this Photon VM, we validated that from Photon VM we could reach, we could ping this 1.5. We haven't yet validated the outbound, so we'll check this once that configuration is complete. And then one more flow is inbound into AVS. So what we can do is we can put this Photon as a backend to this app gateway, and then we can validate this pink flow, and that would make it complete. So while we wait, let's go ahead and just add this. I do have an app gateway already provisioned, so let's go ahead and add this Photon VM to the app gateway, and then we'll run a little web server on it. So I do have an app gateway here. And in the VM pool, we'll just add IP address and we'll paste the IP of the Photon VM. And before I hit save though, I just want to make sure that that one is answering. So it looks like we still have the ping failure, so we'll just wait for this one to complete.
Can you ping it by the IP or 8.8.8? See if the routing works.
So from what I remember, our SNAT setup does not allow pings.
Oh, that's right.
Right. So
yeah,
I think, yeah, is that right? Yeah. So let's just wait for this. Looks like this one did indeed complete. So let's give it a go again. So we'll just do curl. Ooh, that does indeed work now. So so we don't have to run the verbose, just as long as we get the 200. Okay, I think we're good. Awesome. So outbound is working. So let's run a simple web server here. And then what we'll do is, in fact, before I do that, let me just create a small index.html. We'll call this hello world. And then we'll run this, and we'll put this as a backend to our app gateway, and then we should be able to hit it from externally. So this was 10.111.10, right? And so I do have a rule set up over here. And so I'll show you the rule here. So I put the AVS VM in the pool, and I have a rule that sends port 80 to backend AVS pool. Okay, so let's just make sure that the backend looks healthy. And while we wait, let's just grab the IP address of the app gateway. Should be able to. Okay, we got hello world over here, and here we also see that the IP that it's coming from 3.7 is one of the IPs on the app gateway. App gateway is a layer 7 proxy. Show the IP address of the app gateway, and let me show you that as well for completeness. So this one is showing the backend pool as healthy, and app gateway subnet is 172.16.3, the third octet being 3, and as you can see, it's getting 3.7. Okay, so that completes all the flows, Victor, that I wanted to share. So we got all of the flows working. So the blue flow being vCenter access, of course, flows from AVS to Azure, flows from to the internet, and then inbound into AVS. So I think we are now ready to do our HCX MON Lab. Maybe bring your lab here. What do you think?
Oh, let's enable HCX first, right? Because it takes a few minutes.
Sure, yeah.
Okay.
So let's go ahead and do that. So let me go here. So you'll have to walk me.
I can walk you through it, no problem.
Okay.
Let's just go to the Azure portal. It's very simple.
Okay, sure. So we go to Azure portal
And then
we
add-ons.
right, yes.
And then HCX. Then we are going to agree with the terms and conditions, and that's basically just a license. And then just enable and deploy.
Okay, so it deploys the appliance in okay for us.
Yeah.
Okay.
Exactly.
Right.
So if you wanted to see this actually being done, if you go to the vCenter portal, you'll see some task showing. If you click on that recent tasks on the bottom left, on the up arrow, there we go. Pretty soon we'll start seeing some virtual machines being deployed, and they're going to be deployed on the management resource pool.
Got it. Yeah, I do see the management resource pool here. Okay, so we'll see something show up here. Awesome. Yeah, so how about while we wait, Victor, let's do a quick overview of our lab, and then we can start provisioning something where we can test in your lab. Maybe an Ubuntu VM. Okay, so just coming back to the drawing board here. So this is the true scenario that Victor and I started sort of building out our lab scenario. So here you see the green box being on-prem, but simulated on-prem. A real on-prem would look something like this for an HCX lab. Do you want to spend a little bit time on this?
We can talk about this in a little bit more detail. So typically on premises, you will have a distributed virtual switch for most customers, not an NSX environment. That's not really going to be much of a challenge when it comes to HCX. HCX, if you're going to be doing layer 2 extensions, it does require a distributed virtual switch, and we can talk about that in later in more detail. But for this case, since we don't have an on-premises environment, what we have done is just effectively deploy a secondary AVS instance. And we are going to connect them to the same express route gateway that we used for our original AVS environment. If I'm not mistaken, Holly, that express route gateway is non-transitive, meaning that traffic will not flow by default from on-premises or simulated on-premises environment on the left side to the AVS environment on the right side. So what we're going to be doing, so in order to get away from this hurdle, we're going to be using something called AVS Interconnect. And basically what that does is it connects two AVS environments by leveraging the Azure backbone.
So we can connect my SDDC to yours using the AVS Interconnect because they're both in the same region.
Exactly. That's exactly right. So I think we can use the Azure portal for this if you want, and you can go to my SDDC.
Sure. So should we still connect yours to
Yeah, absolutely. We can do that as well.
Yeah. So we can do all of these connections while we wait for the appliance to be deployed. So maybe we do this connection, green connection first, so that we can access your vCenter, and then we will do the interconnect. How's that?
That's perfect.
Okay. So I did. Let me see if I. Looks like this one's still going. And so for us to connect we should go into your SDDC first, Victor, and then this is yours. And then get our
connectivity tab on the top. Yep.
And we'll create a new key over here.
And I think at this point, this should be very familiar to our viewers. This exact same process that we did to connect your AVS environment to the express route.
Exactly. So we can roll through this quickly. So this is going to NN Hub VNet East. So this is going to the Hub VNet in my subscription. And once we have the key, we can create the connections. Okay, so let's grab this key and we will jump back to my ER gateway. My ER gateway currently has connection to my AVS. So kind of jumping back to, we already have this orange. We're going to create this green one. Okay, so now let's go here and we'll say, we'll name this appropriately. We'll use the standard resiliency. We'll pick our gateway. We'll call this and we'll say redeem authorization, and this is where we paste the key. And hopefully this time we pick the right URI. So it's the top one. And we go back in here and we paste the key. Okay, so at this point, before I hit review and create, let's just do a refresh on the effective routes. We should start seeing 10.101 networks. If you remember from before, Victor's SDDC is 10.101. So we don't see any 10.101 yet here, but once we create this, anything else, Victor, here to observe or make observations?
Oh, I think it's pretty straightforward. We should start seeing those that /22 being subnetted out and advertised across the express route.
Awesome. Yeah, so Victor, I did bring some of our whiteboarding to life. I thought that, you know, once the flows start to come in, it would get a little bit more involved. So while we wait, I'll share some of those as well. So let's go see, let's go look at this one. This may take a little while. And then we had done something else. Yeah, so we had also kicked off a few things in parallel. So this one's still going. Let's see if we see the HCX Manager here. And let's go make sure that it also deployed in our portal here, add-on. Yeah, that one's still going.
Still going, yeah.
Okay, so that will take a little while. I think this would be a good time for us to sort of start envisioning a little bit better now with Draw.io. So what we are doing right now is we have this SDDC that we showed you how to create from scratch, the 10.101 networks, and we are just about connecting them to my Azure VNet over here. And then again, we will create a few workload segments here, just like what we did. So how we did a Photon VM. Victor, if you want, we can go create one just for completeness, and then we can dive into creating those L2 extended segments. But strictly from a flow perspective, once we connect this and create this photon VM, all the flows should work just like how it worked for the blue SDDC. And this is the flows on-prem. So we can test this. We can deploy the photon VM. So, and then jumping ahead a little bit, we will see the 10.101 routes going this way, this express route, the green one, and 10.100 going down this way. This is the default. We haven't yet created HCX appliance on this side. So next, what we will do is we'll bring in this AVS Interconnect. And we are in the process of deploying the HCX appliance. I think I'm missing an icon over here. So we are in the process of deploying the HCX appliance here, and we will do the same thing on this side. Victor, do you want to take this opportunity while we wait to talk about the licensing for HCX and what if this was real on-prem, for example, what would we need? So if this was a real on-prem data center, what would we need from a license perspective?
Oh, yeah, that's a very loaded question, especially given all the announcements that have been happening lately. So right now, as of this recording, if you still buy AVS through us licensed, then HCX comes built in with a license. So what that means is that the AVS side of the house acts correct. It acts as the server. It holds the license, and on-premises becomes the client. What that means for you is effectively you can migrate workloads over into AVS and extend layer 2s or VLANs from on-premises over into the cloud, in this case being AVS. If you wanted to do reverse migrations or do a reverse layer 2 extension, basically meaning I'm going to grab a segment from the cloud and migrate it over into AVS, then that's where the licensing changes. Now, this might be a moot point because going forward in a few months from now, customers are going to have to bring their own licenses for AVS. So as long as you hold the license for HCX, none of this really matters. You'll just be able to migrate workloads in and out. And HCX, as far as I'm concerned, is included with VCF.
Got it. Yeah, so for us though, because we are running simulated, we'll still call this client, but we will get the license through AVS.
Yep, correct.
Okay. So this is the client side, this is the server side. And so, we're just about ready to do this interconnect. And once that interconnect is done, we expect these two appliances to be able to talk to each other.
Yeah, and then it's going to be across that interconnect because again, to repeat, that express route gateway is not transitive, so we can't go north and then back down south.
That's correct.
You got to go east and west.
Yes, so we will go over this interconnect as opposed to transiting through here. So
I think we're ready to start doing that interconnect portion. If you want, we can go to my SDDC.
Sure. Actually, let's look at what just got completed. This one was the express route connection. Yeah, so maybe we just validate the routes while we are here. Okay, so we are able to see all the 10.101 routes. And at the same time, this one would take a little while, right, Victor, the HCX add-on, so we can continue. Yeah. Okay, so let's just validate that we can reach your vCenter now.
Sure.
Yeah, so I did I did put shortcuts to your lab so we could kind of expedite this experience. Okay, so we'll grab this. And so that's the login for vCenter. And okay,
There you go. Yeah,
perfect. So we can get to
works.
both. Yeah, connectivity works. Should we get your, you were saying we can go ahead and do the AVS Interconnect. Should we try to set the segments and DNS DHCP first before we do the interconnect, so we actually have something to test against?
Yeah, we can do that first if you want, or we can do it later. It's up to you.
Yeah, let's go ahead and first create just set up all of the basics. We can just roll through it very quickly for your SDDC because we know that how that is done. We did a deep dive before. Yes, we'll create the same similar kind of setup over here. So we'll just go ahead and do the red segment here.
We probably don't want to color red because if we extend it, then it will show us red over there. So we might want to do another color.
So here, there's a good point, Victor. What I was thinking and kind of jumping back to the drawing board here, I thought we still create, maybe not call it red, but we can call it like on-prem red, maybe, just to kind of keep this continuity. And then we will add like a layer 2 segment, the one that we want to extend. We can call it web app DB. So we'll call that one web, but that would be the extended segment, and this would be what I call the local segment, just to so that we have something to test against. What do you think?
Yeah. Well, I'm just concerned about, yeah,
The
okay.
red.
I say, yeah, sorry, no. I see the EIPs are different, 10.101.11 versus 10.100.
Oh, yeah.
Yeah, it's good. Then, yeah, this works perfectly.
Yeah, sorry.
Yeah.
I thought I changed it, but this one was missing. Good catch.
Yeah.
Yeah, so 10.101. So we'll call it on-prem red segment just so we have some structure and we have something to test against. And then when we do the extended one, we will call it 10.101.21. Okay, we haven't got to that point yet. We still need the interconnect up. All right. So let's go ahead and quickly run through all of our segments. So we'll call this Victor on-prem red segment. And just keep me honest here, 10.101.11.0/24, just so we don't mess up any.
That one, the gateway is that one.
Oh, right, yes. I always forget this part. And then, so we first create the segment. Then we'll go ahead and create DHCP. We cannot do anything while it's spinning, right?
Yeah, correct.
So while we wait, I'm just going to take a quick look at what we used for DHCP on. Oops, I think we can check it here as well. Just to match the segments, so we'll call it 1016.2, right? For yours. So it looks like this one did complete. So we'll refresh it. Refresh it here. Okay, so that's that. And then let's go ahead and quickly set up DHCP. So we did DHCP server. And 10.101.6.2/24, right?
Yeah, that sounds right.
10.101. Okay, perfect. And so we now have a DHCP server, and DNS should already be baked in to the AVS, and so it's 10.101.0.192. So everything is looking good here. And why don't we, while we are here, why don't we swap this to use SNAT so we can egress locally?
Sounds good.
Okay, awesome. We're making progress.
Yeah.
Okay, so good. So now we will go and then we'll go on the NSX Manager side and validate all of this as well.
We can validate now while we wait.
Sure. Yeah. What did you want to validate the segments?
Sure. You see that the on-prem red segment be created.
Yep, it's that. Yeah. It's there. And then let's see. Did we want to?
Yeah. Well, we're doing DHCP range. We can do it here if you want.
Yeah, let's do it. So DHCP range. So set DHCP config. So it's already set to DHCP server.
I think it's a gateway DHCP server. Yeah.
Yes, gateway DHCP server, and then the ranges we want to give is, so this is good, and then we put the DNS as 10.101.0.192. How's that?
Looks good. Looks very symmetrical.
All right, so let's go ahead and save this, save it here, and we're ready to deploy at least one VM here, and then we can test some. So after interconnect, we can at least ping between the two.
Yep. So should we deploy the virtual machine?
Yes, let's do it. So let's.
Yeah, let's create a new folder.
So we do a new folder here? Yeah, so we created
new VM. Yeah, there you go. New VM and template folder. Let's call it production.
And then we can just we did the deploy OVF template, right? It took a little bit, but we have other things to do while we deploy it. Right, so we'll wait for that to complete.
Let's do the
interconnect.
The interconnect, yeah. While this deploys.
Sure. Okay, so for the interconnect, we will go to let's start on my side maybe. So let's go on to this one is this my side, and then we can create it. We can do an AVS interconnect over here. Let's do add. You're good.
Okay.
Yeah. So what do you think?
Yeah, there shouldn't be any overlapping IP space. That wouldn't be good. Hopefully
No.
Hopefully we did our job correctly. And let's hit create. They should take a few minutes.
Yeah. So here looks like the HCX add-on is completed. So we could go take a quick look.
Yeah, so actually if you go to the add-ons page, then migration using HCX, you should see the link. Yep, so we can copy that and put it into your jump server.
So I'll keep all of mine together here. So that's not confused with the ones we have for you. And so going back, we should be able to get the credentials.
It's the basic. Sorry, I was still muted. It was. If you go to the SIM credentials, you can just go to the VMware credentials. It's the same one as vCenter.
I see. Awesome. So this is one side HCX. Should we kick off the other side HCX so that it takes a little while, right?
Yeah, it does take a little while, so we can kick out that process.
Okay, so let's do that. So now we go into your AVS, we send all AVS here, and then we go to add-ons and we kick off.
It's still,
private cloud is still updating.
I believe this is the AVS Interconnect that is happening.
Right. Okay, so we'll wait for that. We'll wait for that one. And so just for completeness, just kind of very visual here. So we've completed deploying this HCX. We kicked off this AVS Interconnect, and we're just waiting, and then we'll do this next, right? And then we will have all of the connectivity sort of complete before we go into the L2 extension. So we paused the video, and as you can see now, under the AVS Interconnect, and again, this is my SDDC, that you can see that we are connected to Victor's SDDC. And likewise, if we go in Victor's SDDC, let's look at the corresponding side, and you can see that it's connected to my SDDC. And the is source is set to yes on this side, and on this side, the is source is set to no. Okay, so now we have the AVS interconnect in place. Let's go take a look at the VM that we deployed in Victor's SDDC. So let's go take a quick look. So here we are in Victor's SDDC. I'm on the vCenter, and I did open the VM here. So let's clear it out. And again, if you are doing this for the first time, the default password when the VM comes up is root and change me. And I have listed some of the useful commands for the Photon OS over here. So with that, let's go ahead and double check. The VM did indeed deploy, and let's start with IP adder. We'll try to ping something in Azure, so 172.16.1.5. That's our jump host. That should work. And then let's also try the curled command. We can remove the V. And Google works as well. And for completeness, we'll just try to even look at what we got for DNS. And as you can see, we got the 10.101.0192 for DNS. Okay, so let's try to run one more test where we will try to ping using the AVS Interconnect. So if we look at the IP adder here, we are on the on-prem machine, so simulated on-prem, so 10.101.11.10. And let's go to the Photon VM in my SDDC, which is 10.111.10. So we'll try to ping 10.101.11.10 from here. And this is indeed pinging across the interconnect. Let's see if there is an SSH here. And sure enough, we get the SSH prompt. So this is indeed going over the interconnect. So just from a visualization standpoint, what we just did is we connected this yellow box, which is the simulated on-prem, with the blue box, which is the AVS side, and we used the AVS Interconnect, and we just tested the ping between this VM and this VM. Okay, so AVS Interconnect is now working, and let's kick off the HCX install. So we did complete the HCX install on this side, the AVS side. So let's kick off the HCX installation on Victor's SDDC. So we are in vCenter AVS, and we'll go to add-ons. We'll go here. We already did this for my side. Again, this is the simulated on-prem. So we go ahead and click enable and deploy. And while we wait, let's take a quick look at this side as well. Here you will see that this is on my side, that we do indeed have the HCX deployed. Okay. So again, this takes a little while, so we'll pause the video here, and then when we are back, we will have both the HCX appliances deployed, and we will be ready to run the L2 extension. So picking up where we left off, we just completed deploying the HCX appliance in Victor's SDDC. And just for completeness, this is exactly where we are. We have this appliance deployed and this appliance deployed. So Victor, let's jump on to the vCenter side. Maybe we can make some observations there. What do you think?
Sounds good.
Okay. So here we are in the vCenter. I hope I'm still logged in here. So I think I'll have to punch in your credentials again. So this is my SDDC again, and then Victor's SDDC is the simulated on-prem. So Victor will start with mine. I'm sure the observations are pretty similar on both sides. So let's see. Do we see the pool?
Yeah, there's the HCX Manager.
Ah, okay.
Yeah, so,
I see it. Yep.
So it's been deployed.
Uh-huh.
And
It
then we
got
just
10.100.09. I like to look at IPs.
Yep. Then we see that also on the simulated on-premises side. And next, what we will do is log into the HCX appliance. So I see you have it open already.
Yes. Let me just get the credentials. I don't know if I have the credentials yet, so let me just get it. Any other observations that we need to make from just strictly from the VM side?
So one thing that we're going to need is that activation key, but we can get that later. We can add an activation key. Okay. And that's basically the license for AVS.
Okay, so let me just punch in. Sorry, I think it times out. So this is, I just want to make sure I have the right one. So this is on my side, and then let me get the credentials for your side as well. Okay, so the right hand side is Victor yours, and this one is mine. Okay. So what I was saying is do we need any other observation at the VM level other than it's just connected to one network, right? Just one network. Okay, cool. All right, so I'll have you help me navigate.
Yeah, so if you go to, this is your site, go to the site pairs real quick.
Okay, so we are on the AVS side, my side. Okay.
Yeah. And we're going to create a new site pair.
Okay.
And then we're going to need actually the remote HCX URL. So if you go to the URL on the simulated on premises, you can copy that all the way from to.com. There you go. Actually, is it hybridity? I can't remember. It's been a while. Hybrid to use it. Yeah, we can try it like this and see what we get back.
Okay, so I'll remove the tail. Okay, so that's that. One is the credential for the remote.
Correct.
Okay, so then. Okay, good to go.
Yeah, create. Yep, and then import the certificate. Yeah. Okay, there we go.
Awesome.
We have our side pair. Good.
Awesome.
Now,
so this happened over AVS Interconnect. I do want to call out that in the real scenario, it would either happen over Express Route Global Reach, or if you have, in this scenario, we cannot do ER to ER transit, but if you have, let's say, vWAN, you could do ER to ER transit, or you can use global reach. So a couple of different ways to do it. For the lab, we are doing AVS Interconnect. But it does require private connectivity, right, Victor?
yeah, that's correct. Yeah, I don't believe public connectivity is currently supported.
Okay, so this looks healthy then?
Yeah, it looks good. Now let's go into the interconnect on the left side on the infrastructure. Now, HCX has multiple appliances that it gets deployed. One of them is the HCX Manager, which was deployed when we kicked off the HCX add-on. There are multiple appliances that can be deployed additionally. For one of them is the Layer 2 extension appliance that is responsible for basically extending Layer 2 networks over IPsec tunnels. There's the WAN optimization appliance, and there's also the appliance responsible for the storage replication required for moving the virtual machines from one side to the other. So we'll see that right now. So if you go ahead and select Create Service Mesh.
Yeah, one thing I thought we should check is if I go on the other side, is there a concept of client versus, in this case, we won't see client versus server, but we should see the other.
Yeah, so in this case, you're not going to see it because they're both AVS environments technically, even though the mine is simulated, but it's licensed with AVS licensing, so that makes it also a server. So right now we're server to server.
Okay, so before we create the service mesh, Victor, do we want to look at the compute profiles on both ends, on this end as well as the other end? So this is yours.
Yeah, so what a profile does, since I mentioned before, HCX has multiple appliances, and when you deploy appliances manually on VMware environments, you had to specify which port group is the virtual machine going to reside, which cluster, what resource pool, what folder, data store, etc. And since we are doing this with multiple appliances, because HCX is a mesh of appliances, instead of doing it one by one, we define what is called a profile. Now, on the AVS side, on every AVS environment, this is automatically done on your behalf. You have network and compute profiles pre-created. If you were to install HCX on premises from scratch, you will have to create these compute and network profiles for yourself. It's not that difficult. You just need IP spaces and know where your virtual machines are going to reside. But that's pretty much what the profile is. Now that we have that created, Nahali, I think we're good to go. We can create the service mesh.
Sure. Yeah, let me get both of these screens in the recording. Yeah, perfect. So service mesh. So this is on my side. Yep.
And it's basically telling us we're going from your side to my side. Yeah, so continue.
Victor, does the segment that we need to extend need to be ready, or because I haven't created extra web app DB segments yet?
We can do it later. No,
Okay,
no worries. Yeah,
Okay.
and then do where it says select source compute profile on the drop-down menu, and we should see something that says compute. Yeah, compute profile.
Okay,
Like I
got
mentioned,
it.
it was pre-created for us, and the same thing on the remote side, because this is basically what it's going to do. It's effectively also going to deploy the service mesh on the simulated on premises. So you see where it says select remote compute profile on the right side. Yep, and that's pulling the profiles from the other vCenter.
Going over the AVS Interconnect.
Yeah, there we go.
Okay.
There's the compute profile. Yeah, continue. And here are the services that I mentioned. So the one optimization appliance is optional. Basically, it does what it says. It's a one optimization appliance. I highly recommend that you always deploy it. You can also do cross-cloud vMotion migrations, bulk migrations, which we'll talk about in more detail. It's basically moving a set of virtual machines at a time. Bulk migration does require a power cycle. Replication-assisted vMotion, basically you can schedule vMotions ahead of time, and what that does is gives you the ability to forecast your storage requirements from a networking perspective. So, for example, if I want to replicate a 1 terabyte storage VM, I may want to schedule that 1 week or 2 weeks in advance, depending on my bandwidth requirements, so that I can have plenty of time to do that cutover. And then
Sorry, I
obviously
missed. Which one is this the
that's
storage?
that's the replication assisted vMotion migration. Yeah, it's
I
just
see.
it's just a service. And then the network extension is that component. The things that I want to talk about real quickly is disaster recovery. Technically, HCX can do disaster recovery, but we don't recommend it for that particular feature. We have there's a lot of tools available to you for DR purposes, but it can do it. OS assisted migration, we're not really going to touch that in this particular lab, but if you want to migrate virtual machines from non-VMware environments, that's where you will be using OSAM. Again, we don't have a Hyper-V or a KVM environment to migrate virtual machines. But if you wanted to do, for example, physical to AVS, you will use OS assisted migration. But for right now, we'll just, Nehale, if you want to unclick the disaster recovery one, just uncheck it.
I see.
And we'll leave everything else as is, and we'll do continue. And there's the uplink network profile. So now we're going into the networking side, right? So we did the compute before. Now this is where the virtual machines are going to be created, and then uplink we deploy. AVS automatically deployed a segment called uplink. So go and then select close, and then the same thing on the and then basically what this does is what port group do I have that has access to the outside world where HCX can use as an uplink. That's all we're doing. And select continue. And as you can tell, Nehale, it's giving you a nice network architecture or what's connected to what. Yeah. And then it also shows you the interconnect, which is basically the TCS, the HCX uplink connectivity. The orange line shows you the uplink.
I see.
Yeah, the management is represented by the black segment, then the vMotion, because there's HCX does contribute to the vMotion network. And then the other one is the layer 2 extensions. So let's go ahead and
hit continue here.
Yeah, hit continue. Yep, this is fine. Just continue. Yeah, and then one thing that you can do here is that you can set up the limitation. So if you have limited bandwidth from on-premises over into Azure and you don't want HCX to hog all your bandwidth, you can set up limitations here. For our lab purposes, we're not going to be doing that. So we'll
How
just
about
go
the
ahead and
MTU? Is it already set, or do we get the?
we actually missed that portion. It was on the previous slide.
Should
And I
I
think
go
that
back? I think
and
it's important. Should I go back or no?
yeah. We just go back. Sure.
If using this, just don't want to lose everything we did.
Oh, yeah, we just lost everything we did. Yeah, so here in the Hali is where we're going to be talking about the MTUs, and since we're going to be talking about IPsec tunnels, I think it's probably a good time to introduce our friend Jeff, who's joining us from Broadcom. Jeff, do you want to say hello?
Hi, everyone. Nice to meet you.
Hey, Jeff. Yeah, so in your experience, Jeff, how do you see this configured? Because there is L2 happening over IPsec tunnels. So
it's a good question. And as we'll see in the next tile or the next part of the configuration, within HCX, you can encrypt the traffic in transit. So depending on what customers would like to do, HCX will build the layer 2 VPN and also put it inside of its own IPsec tunnel in order to keep that traffic encrypted. But there are certain use cases where customers need to send that traffic, even though it's encrypted by HCX, over a secondary tunnel or SD-WAN, some other tunnel technology. So if that's the case, if we're essentially encrypting the traffic with HCX, where it creates its own IPsec tunnel, and somewhere in the path between the two HCX instances, or in this case, the two AVS instances, there's a secondary tunnel or an SD-WAN connection. We have to be able to adjust the MTU on the HCX side because we're essentially putting an IPsec tunnel inside of an IPsec tunnel. So here's where we would do it. So here we have a chance to override the MTU, and our recommendation, and Victor, you can comment here, we recommend to have the starting point at 1350, the MTU size of 1350, if we're in a situation where we're putting, if we're encrypting the traffic, number one, on the HCX side, so it's building its own IPsec tunnel, and we know somewhere between there's another IPsec VPN, we would want to set this MTU to 1350. Why? Because otherwise we'll get fragmentation, and even though it'll continue to work, the performance will be degraded. So normally we would recommend, if there's an IPsec tunnel in between, independent of HCX, we would set the MTU to 1350.
excellent. Thanks for those insights, Jeff. Appreciate that. So with that, should we continue then?
Yeah, I think that's good. Yeah, let's continue. Yeah, and we already talked about the one optimization configuration, and then we should be good to go. Let's hit continue. Oh yeah, and then we just need to name our service mesh. So you can leave it as Interconnect 1 if you want. And the reason why we have this is because it depends on your architecture. In this case, we're just doing one site to another site. But if, for example, you want to do two sites to one, then you're going to need to deploy another service mesh.
I see. So this is one-to-one, but you could have it to other sites, other on-prem sites.
So it will be more like it will be more from AVS to on-prem. So I wouldn't call it interconnect, but more like AVS to on-premises. Yeah, and then yeah, that's fine.
Awesome. Is there any validations that we can do on the other side?
It's going to take a few minutes. If you go into the vCenter.
Into the vCenter, okay.
You're going to see pretty soon some tasks happening, and basically is the appliances that we discussed are going to be deployed automatically.
And they would be deployed under this resource pool?
Under the management resource pool, correct.
Okay, yeah, and so just to dovetail into what Victor mentioned, Holly, if we go back into HCX, into that service mesh, there's a tab there that says tasks. It has number 1 next to it. This is where we can start to see all the phases of the HCX deployment, and those should also be reflected at some point within vSphere, but this is probably the best place for consumers to look at that first, or partners and find out what's happening at the HCX level, and then make sure that we're also reflecting that at the vSphere level. But more or less, because HCX is registered with vCenter, the information should be aligned.
Yeah, great place to troubleshoot as well. Thank you, Jeff. Yeah, so we can pause the video here. Okay, so picking up where we left off, we kicked off the create service mesh, and this is where it is. Is there any validations you guys would like to run? Victor, Jeff?
The easiest way to validate this is if you look at the HCX services and you see all green
All
dots.
greens.
Yeah, so that means that everything went well. So like you remember, Nahali, in the beginning when we deployed the service mesh, we were checking the services that we want installed.
Yes.
So in here, you should be able to see, if you just put the cursor over the service, you see the interconnect service is working,
I
while
see.
optimization. And there's a network extension service.
This
So
is the one of interest, right?
Yeah. And maybe, yeah, like Jeff mentioned, that's basically an IPsec tunnel, layer two VPN over IPsec. Even though we haven't extended anything yet, the IPsec tunnel is already established between the two network appliances. Okay. And then all the other services are also working. So I think at this point we're good to go, and you should see a number of virtual machines deployed on premises or on both clouds. There we go.
Yeah, so these are the 4 appliances. Let's validate it on the other side as well, right?
Okay, awesome.
Anything else, Jeff, you want to look at?
No, I think that looks good.
So I observed this 10.100.068. I don't know if it was there before, but I happen to notice it now. Do you guys want to comment on this one?
Yeah, that's actually yeah, great point. I almost forgot about that. So if that 100.068 is actually the interconnect appliance. So if you click on that IX11 virtual machine.
Yes. Yeah. Okay. Yeah.
Yeah. If I remember, you see it has the same IP address. So on the back end, for those of you that want to geek out on how this actually works, the interconnect appliance is actually acting as a host, and the host has access to the storage where the virtual machines that we want to migrate. It has the same access. So it's using vSphere replication in the backend to replicate them, and also vMotion. So the easiest way to do is just to make this virtual machine act as a host, and that's why it was registered as a host on the vSphere environment. Jeff, anything that I'm missing or that you want to add?
No, that was a good summary.
Awesome. And another question I have, which I get this in the field a lot, but when we did this interconnect, I was checking this earlier, and both the sites were resolving to private IP. So this interconnect did happen over private networking. Is it what is the best practice for it? Is it possible over public? If so, what are some of the gotchas?
Yeah, so maybe I'll cover that section. We can migrate using HCX from on-premises to AVS over the public internet. It does require that we introduce a public IP service within the AVS SDDC, which is also supported, and then terminate that HCX service on that public IP address service on the AVS SDDC. So yes, it is supported. It is something that we've done with other customers, and we can cover that as well if needed.
Got it. Thank you. So as long as this can have a public-facing IP on the AVS side, which NSX does support, you could do it. Is there like a recommendation of one versus other, public versus? Is it better to, from a latency perspective, I would think, to use?
Yeah, I mean, obviously you're right, Nahali. Going over the internet, there's no guarantee of service because obviously it's a shared environment. So I would say a lot of the customers who've done it just want to make sure that the migration traffic is out of band, but they intend to keep their network extensions within their own backbone because they can guarantee that let's say level of service of the transport itself. So it really depends on the customer, but there have been corner cases where they've done that, and it is fully supported.
Okay, great. That's what I wanted to know, that it was supported. Awesome. Thanks, Jeff. Great insights. Yeah, so let's kind of now do a little bit of envisioning, and then we'll go ahead and configure this lab end to end. So what we just did, just kind of from an envisioning perspective, we just deployed the interconnect, which the service mesh, which behind the scene deployed all these services that Victor mentioned. So what we're going to do next is we'll create a segment on the on-prem side, the simulated on-prem side, and we will extend it. Then we will, so we've called it web app DB, so it would be a 3-tier app, and we will extend all of these 3 segments. Then we will, so behind the scenes, Victor showed this appliance network, NEA network extension appliance, which behind the scenes is already deployed. And then we will look at flows. So first we will look at the flows from the VM that is on the AVS side to Azure. As you can see, the flow would look something like this. I think I'm going to have you, Jeff, comment on these flows just a little bit and how this is not optimal.
Nahali's correct. So as we first introduce HCX and do the network extensions, HCX MON is disabled by default. So as we extend those networks, the only way we can get in and out is via the default gateway that was originally on premises. So even though we've extended networks from on-premises into AVS and we've migrated the workloads from on-premise into AVS, the only default gateway that's currently available is the one that is currently indicated by Nahali, 10.101.21.1. And that's the only ingress-egress point that we can use. So effectively, depending on the workflow, we always have to revert back to the on-premises for that traffic.
Thank you, Jeff. And so these segments are, the default gateway is here. So the tier 1 on this side is the default gateway still for all 3 segments. We'll look at the internet flow. So same logic applies, like Jeff mentioned, the default gateway is still on this side. So we'll look at those flows, and then we will look at, of course, this VM to VM flow would be over that interconnect, and then a VM in one segment to a VM in another segment. Jeff, maybe you could talk through this one. I mean, I've shown more of a logical flow, but I assume that it does go through somewhere through that appliance.
Correct.
Extender. Yeah.
So as we attempt to get, if we migrate a 3-tier app from on-premises into AVS, at some point the different tiers will want to communicate to each other, web to app, app to database, etc. And in order to communicate to each other, and since the networks have been extended, the only way to get between segments is to go back to the default gateway, as mentioned, on-premises, to go from, let's say, segment green to segment red to blue, etc. So for every VM that we move over, we have to be conscious of how that traffic flow works for each application. And we might be in situations where, as we indicate here, traffic has to trombone back to on-prem, even though the workloads exist in AVS.
Yep, excellent point. Yeah, tromboning is the right term here. And often they call it hairpinning as well, or is that different, Jeff?
Correct, that's the same terminology.
Same terminology. Okay, awesome. So that's VM to VM, and then optionally and then I'm going to stop right here from an envisioning perspective, but like Jeff kind of set it up for us, we are going to then enable MON and see what the behavior looks like. In the interest of time, what I have done is I went into Victor's SDDC, which is the one simulated on-prem. And for the benefit of our viewers, I'll just show us all the 3 segments that I have created. So app, DB, and on-prem, and the third octets 21, 22, and 23. Okay, and then on the vCenter side, we have, let me jump back to the vCenter and NSX side. On the vCenter side, you will see that we have 3 VMs, Apple one, DB and Photon. So if we we'll just quickly jump on the web console for the web VM, which is here. And we'll just observe a few things before and after, and we'll just do curl ifconfig.me, and this VM right now is egressing from the local side from the on-prem side. Okay, so that's just to capture that. And then anything else that you guys want to see from a starting point before we extend?
Victor, I think that covers most of it, right?
I think Victor might be muted.
No, sorry.
Okay.
Yes, that's accurate. Yeah, no, I think we're good.
Good to go. Yeah. And I did verify that between so this is the web VM, and I did verify that 10.101.21, actually 22.10, which is the app, and 23.10 is the DB. Okay, so we have all of this on the on-prem side. So yeah, one of you maybe could help me create that extension.
So if you go to the NSX side, sorry, the HCX side on the simulated on-prem,
Yes.
I can walk you through that process.
Oh.
All right, so rule of thumb, really you want to start the network extensions from where the VMs are being migrated from. Right, so in this case, our migration is from on-premises over to the cloud side, so that's why we are starting the extension from on-prem. So we just go ahead and select create a network extension. From HCX. Yeah, have you seen this?
No. What's HCX Cloud? Are they named the same on both? That shouldn't make any difference, though.
Yeah, so I think we hit a bit of a problem here, Holly. We didn't. I wasn't checking when we did our side pairings. It looks like we initiated the side pairing from the cloud side, and going to on premises, as opposed to the other side going from on premises to the cloud. Letting us extend because because we started from the other direction. So
no
I think
problem.
at this,
I think, yeah, can we correct this? Like, what do we need to do? This is good for our viewers to kind of see it happening, and maybe we can correct this.
yeah, so what we can do is break the service mesh and break the side pairing, and then do the pairing in the correct order, and then we deploy the service mesh, and that should fix the issue.
Okay. And should we maybe then just deploy one appliance now that we've shown how to do all of it? So that would, in the interest of time, we can just deploy one appliance, right?
Yeah, we can do the network extension and the interconnect, which are the requirements for what we are trying to do.
Okay, so which one would that be?
The IX and the NE.
Okay, perfect. Yeah, so that let's do that then. So the way we can delete it is through this interconnect.
Yep.
And it will delete it from both sides, right? So
Yeah,
this is the on-prem.
Yeah, go ahead and hit delete.
And while it's deleting, would we be able to create another, we'd be able to kick off another one from the on-prem side? I'm sorry, from the AVS side?
We can, but we still have to remove the side pair and then do the side pair correctly.
I see. And then another observation, maybe is there a way to make this different, the naming, or is it too late? Is it because it's an AVS, it's giving it the same name?
Yeah, I think it's because it's an AVS, it's giving it the exact same name.
Okay. All right, so we'll pause the video here. Do you think this looks like it will take time either way? So it looks like this finished. Victor, do you want to drive and get this? Yeah.
Sure. So I'll go to the side pairs and I'll break the side pair.
This is good in a way because we do in these sessions show real-time troubleshooting. So if we break things, we fix it together, and good learning.
Okay, now that the service mesh has been deleted, and let's check out side pairs. Our side pairs should also be gone. So,
Just for the benefit of our viewers, just to avoid that mistake, we aligned the tabs. So the left side now is on-prem and the right side now is AVS.
yeah, thank you for that. So we know that. Let me just grab the URL from the cloud side because now I'm initiating the pairing from on-prem.
Yeah, so 93 is AVS side. Do you want me to paste the passwords for you?
Sure. Let me just.
This is the password
For your environment.
AVS. So for the AVS side, okay.
Now it's created. All right. Now that we have the side pair, we're going to go ahead and deploy the interconnect. We already talked about the compute profiles and the network profiles and the roles in the previously, so we'll just continue.
Is there a way to change that name, Victor, because they both say HCX Cloud, or no?
No, that was done when it was created, when HCX was deployed, unfortunately,
Okay.
because it was all automated using Azure scripts.
I see. In a real world, though, it will not happen, right? They would all be different because on-prem would be different.
Yeah, on premises, you will have the ability to name the HCX instance.
Okay.
So for sake of time, we're not going to deploy the one optimization appliances, and they're not doing awesome for disaster recovery. Then anything else, Jeff, that I'm missing?
That looks good.
So the uplink profile. About the MTUs, we talked about the overlays.
Victor, just one thing I thought we should double check. No more appliances in the vCenter inventory. If you want to click on that just to double check.
Oh, they're gone.
Okay, perfect.
Well, management VMs. Yep, no, they're gone.
So, from both sides, they have to be gone, right?
Yeah.
Under the yeah. Okay, cool.
We can pause it here.
Sure. We can click on the tasks now that Jeff has shown us this view. Yeah, this will take some time, so we'll pause the video here.
That's fine.
And it looks like and maybe for the recording, Holly, if you just open that arrow on the left-hand side to let the other tasks show what's going on. I think we captured that yesterday, but usually at 60%, it'll sit here for a few minutes and then go to 100%. Looks like it's probably getting to the mobility agent. Oh, it's still doing the appliances, okay.
gonna take longer than 5 minutes, but it will.
Yes,
Okay.
it will. The video, and now looks like Victor, it did finish, right? So if you go to the interconnect screen and the site pairs.
Yeah, we should see the service mesh
Yep.
completed.
And then the appliances got deployed in
Correct.
vSphere as well, right?
Yep.
Yeah.
Yep.
Okay. IX 11. Okay. Perfect.
So now let's go ahead and do the network extension real quick. Take some time to populate the inventory. So we see the app on premises, the database on premises, and the web. So this is 3 tiers. So let's go ahead and select next. The good thing about this is that we can do multiple segments at once. And Jeff, remind me if I'm not missing anything. There's about 5 segments that we can extend per network extension appliance.
I think the total, so the appliances are deployed as if they're VMs. 2 are being used for uplink and management. So I think you can go up to 6 network. Yeah.
Okay. Got it. Okay.
So, sorry, 8. So it'd be 10 minus 2 is 8. Sorry.
8. Okay. Got it. All right. So, Nehali, I think I'm going to need your help on this one because I don't remember the IPs. So we need
Sure.
the IP address for the
app.
App. Yeah.
This is on the on-prem side, right? So 10.101.22 is the app. So 21, 22, and 23 is the third octet. So this is app. Okay. So this is DB is 23. So 10.101.
So a lot of people have asked, why do I need to put the gateway IP address into a layer 2 network extension appliance? Because it really doesn't need to know if it's just extending a layer 2 connection. The reason for that is because if we do enable MON, HCX will take these IP addresses, these gateway IP addresses that we've applied here, and when we connect the gateway on the AVS side, it copies these and pastes them onto the other side, which we'll talk about later in the demonstration. But this is where it gets that information from the users. When we build these network extensions, technically we would not need that if it was just layer 2. But because there's the option further on to enable MON, it needs to know the gateway IP address that's been on premises, and this is where it gets that IP address information through that automation process. So that's why we have to enter the gateway IP for the layer 2 extensions.
Thank you, Jeff. And for right now, we're not going to enable MON for the moment that we do the layer 2 extension. We'll do that one later because I think most customers, they probably do the layer 2 extension and then they enable MON as they start their migrations.
Good point.
Yeah,
we'll hit the validation and submit. Should take a few seconds.
And would we see like a segment appear on the other side? Is that what would happen?
Yeah. So
yeah, this is the fun part. I would love to see how that looks like.
Yeah. So from a vCenter perspective, nothing changes. You will still see the same segments on yes. So you'll see the app, database, and web. Now, if we go into the vSphere environment, let's see how fast this is.
And this is on the AVS side.
Yeah, you see the L2E on app,
nice.
L2E DB, L2E web.
Nice.
Right? And if you go into the NSX side of the house, I'm not sure if we have NSX here.
We do, the first tab, yeah.
This is the cloud side, I think, right?
This is the AVS side, yes. 93 is my side.
Okay, and then we go into segments. We should see L2E, L2E, L2E.
Nice.
Yeah.
So is it extended at this point?
It should be. Let me just go into HCX and make sure no, it's still doing its thing. So the network extension appliances are probably finishing setting up the layer 2 VPN. So the segments were created, but the layer 2 VPN is probably still being configured.
So one thing we could do, Victor, is I've already created a VM on the AVS side. Maybe we can attach that to one of the segments.
Sure.
You,
Function.
yeah, so it's to see it says Web02 AVS. It's currently attached. So if you edit settings and change the network, yeah. So then we can do a quick test with that one.
We'll put it on the which one? The L2.
So web, it's named web. So just go to the web here.
L2
yeah.
web.
Yeah, because I named it Web02 on the AVS side. Yeah, so perfect. And then we can turn it on.
All right, so now that we turned on our virtual machine, it's on that same layer 2 extension. If you want to go ahead and log in.
Yeah.
All right, let's check out its address. So it hasn't gotten its IP address. So you know what? I think this is because the security profile on NSX it's blocking it. Let me see if we can fix this real quick.
Sure.
But this is before the migration, right, Victor?
Yeah, exactly. This is before the migration.
Okay.
Holly,
So we just attached. Oh, yeah. So I think it's getting in the way. Okay, try it now.
Or do we even have a DHCP service set up on NSX for the when it starts?
The DHCP service, we have the DHCP server on the NSX side on-prem.
Yes, that's how the original VM was getting it, right? So we have a VM in the web segment. So, but go ahead and double check, yes, because the on-prem VM did get an IP address.
Okay.
But which VM did we just look at? Oh, we attached one on the target side. We didn't migrate it, right?
No.
Okay. Exactly. We just want to check the pings work across the L2.
Oh, okay. Yeah.
Okay. Yeah. So web on-prem.
Yeah. So edit DHCP config are there, and yes. Yeah. So it's configured.
Yeah.
So here's the NSX, and then this segment.
The web segment you're fixing, right? You want to look at the 20, the web 21, yeah.
Okay, so not here because we want the on-premises to act as I think it's on segment profiles. Segment security. Just create a new segment security.
I see. So it's not forwarding the DHCP discovery packets across.
Yeah. All right. So for this segment profile, Nahali, I think we'll enable the BPDU filter. And then we'll disable the rate limits and the route advertisement guard. And let me see if this works. We'll save it. Oh, so DHCP. So L2 VPN DHCP. The error is not this. It doesn't like these max right here. What happens if I just Then we see the our segment security now has the L2 VPN DHCP profile that I created. Select save.
And this is on the web segment, right?
Yeah, this is in the web segment. So now let's go to your. What's the command for this? I'm for restarting on the networking services on Photon. I was just going to restart it.
Let's restart the VM. Victor, I don't remember the Photon OS command to restart the networking services. So there you have the IP 21.11.
Awesome. So now let's try doing a ping over across the layer 2.
So this is the same segment VM.
Yep.
Is working. Awesome. This is good stuff. And then we can try 22.10. This is cross segment. This is 23 to database segment. And then if I do curl, I got all excited. ifconfig.me. It is egressing using 79.35, which is the other side. I had noted down. Yeah, so this is the on-prem side.
Yeah. One thing to point out is the latency. So, like, do you see
Ooh.
that 2.25 millisecond latency
Mm-hmm.
that's going across the layer 2? Even though we are in the same Azure region, you should expect higher latencies because your data center is going to be in another location. But just for clarity, let's ping a VM that's not on the layer 2 extension. So if you go to your drawing, Nahali, I think you have a virtual machine on AVS. You have a VM that 10.100.11 segment, the red
Ooh,
segment.
yes.
So I think we have a VM on that 11.
Yes, right? 11.10. Yes. Should we?
11.10. Yeah. So let's ping that one.
Okay. So just to be clear, so we are on the AVS side, and then we ping 10.100 local one, 11.10. So this one goes all the way across, and then it's still working.
Yeah. Yes. Yeah. So this is not across the layer 2, right?
No, it is, right? Because it is because we are going.
So which VM are we pinging right now?
So we are on this one. So let's disable. Okay, so what we're doing right now is we are on the extended segment VM here and pinging this one.
Okay. Yeah. Yeah. So that's going across that layer 2. So
Yes.
next time what we'll see is that when we enable MON, we should see that latency drop significantly to probably sub milliseconds because it's probably in the same host or in the same rack.
Yeah, good call out, Victor. Yeah, so let's record just that piece. So yeah, we do have that ping going to 11.10. And then one more test we should do is ping one of the VMs in Azure. So 16.1.5, which is our jump box. So this one is going over to on-prem and
across the express route. And across the express route, right? So that's why you see the big jump in latency.
Just to recap, we tested to Azure and we tested to Internet, and we also tested to another segment within AVS as well.
Correct.
Yeah, so all the flows are tested. I think we're ready to enable MON unless you guys want to test something before we do that.
I think we're ready.
We're ready? All right. The moment of truth, right?
Yeah. And we do this from the on-prem side.
Okay, so I'll let you control it here.
All right, so if we go to HCX on-prem, and let's do web for now. Edit this. Sorry, expand
Oh,
this.
I didn't realize we have to do this MON change on the on-prem side?
Yeah, on the on-prem side, yeah. Enable it. It just tells you there's going to be a brief outage across any traffic that goes across the layer 2.
Hang on 1 second. Oops, is it saved? I was going to kick off a ping, but it's okay.
Oh, well,
I think you can still do that.
Yeah, let me go ahead and do it. So this, which one should we ping? We'll ping something in Azure.
Yeah, so nothing's going to be fixed yet because the way the MON works is any new virtual machine that gets migrated, it will have MON enabled. But because that VM was already there,
okay, good.
It's not actually being enabled on that particular VM. So
okay, so we'll see the delay after we enable it then. That's good to run the ping going, keep the ping going.
Yeah, and it's still being done.
And the MON gets enabled at the VM level?
Yeah. So Jeff will discuss this more in his PowerPoint, but that effectively when you enable MON at the segment level, any virtual machines that were previously on that segment prior to enablement are now going to be enabled for MON.
I
Right.
see. And how would we fix the one that already existed?
You can enable it manually for each VM.
I see.
And we'll show that right now. So what Victor has done is he's enabled MON on the network extension. That's the first place you enable it. And then it'll indicate which workloads it sees on that network extension. Then on a per VM basis, you can manually change it if it hasn't already been updated for MON.
Got it. Thank you. Yeah, that would be a good exercise then. So Jeff, this will set it up perfect for you for your advanced scenarios that you're going to talk through.
I agree. Okay, so now that we have MON enabled on the segment, we can see a new section at the bottom called Member Virtual Machine. So yeah, right there. So, and I think Victor can pick it up from here.
Yeah, I'll go right ahead. So yeah, so right here we have the virtual machine, and oh, this is going to be interesting because they're both named HCX Cloud. Yeah, so we're going to have to play a little bit of a guessing game. So you shouldn't have this problem on premises because of the naming conventions will be different for you. But my guess is that this is probably going to be the cloud side. That's my lucky guess. We can always come back. But right now, if I do this to the target location and I submit it.
So Victor, just a quick question here. So it is supposed to be the target from the AVS side, right? This is
Correct.
supposed to be okay.
Yeah. And then if I hit submit,
You want to check the pings? Is that how we will know, or?
yeah, we will know. Well, technically, the ping I think might break because we might have asynchronous traffic at that point. But let me double check.
Although that's a good thing. We can double check here.
Yeah. Okay, so it looks like it didn't take. Shit.
I don't see that ping running, so maybe can you
Yeah,
double check?
Control C. Let me Control C out of it. Are you able to do it, or should I do it, Victor?
You do it.
Yeah, because this is a console window. Yeah, so ping stopped working, so you have it right.
Okay, so for some reason the console didn't update. Let me get out of it. Back to it. Oh yeah, there we go. So now MON's enabled. You see the web on premises, it's enabled, and we see the virtual machines that are part of MON. So yeah, so MON is enabled, and we have it as the HCX Cloud. So let me see. Router location 93.
93 is the AVS side.
Yeah, awesome. So then, yeah, so that's what we want, but I think we are hitting a nag because of routing policies. So I'll let Jeff take it from here so he can explain how that works.
Should we see the /32 at this point, though, on the Azure side?
We should.
That's a good point, yeah, if you want to go there.
Sorry, okay. Let's go.
So while Nahali is doing that, two things are going to happen now that we've enabled MON on the segment and the VM. HCX will automatically orchestrate a /32 host route into the routing table of NSX, and NSX will advertise that into the Azure or ExpressRoute backbone. So depending on how many routes we have here, we should see it. We should see that in the effective routes, the /32 routes, and You can scroll down here.
So let's go back to the drawing board, just want to make sure. So this VM would be 10.101.21.11.
/32.
Yes.
Yeah, and so we'll take a look to see if we have that route in the effective routing table. And the reason that HCX injects that is because that will help us control ingress traffic. So we'll have the original route, in this case, the /24 that comes from the default gateway on premises that always existed, and then a more specific route, the /32 host route. So as traffic comes into the environment, it'll know by a longest match rule whether or not it forwards that ingress traffic to the AVS side or the less specific route to the original on-premises side. So here we can start to see that that IP address is being advertised into the NSX environment. HCX has orchestrated that /32 host route. It gets redistributed into BGP. BGP advertises that into the Azure backbone and into this Windows VM. So this is a good indication that those /32 host routes are being advertised. And again, that controls the ingress. So from outside into AVS, where that traffic goes, or outside into on-premises based on the longest match rule of routing. So that's good. Now we have to be, now we still have asymmetrical traffic. What we'll do is try to correct that because we have to influence how the traffic exits or egresses AVS. And we'll go into that next.
Excellent. Thanks, Jeff. So there is, I just wanted to capture the other route, the /24. We should see that one as well, right? Yeah, this one. So this was the original route, and we got the more specific /32s over here.
That's a good
Awesome.
point.
Yeah. And so did you want to, should I go back to this place now?
Yeah, and really quick, Nahali, if we go to the VM where we're running the ping, I think it's the 5th tab there, or 4th, yeah.
Yeah.
So we're attempting to ping 172.16.1.5. Okay, so we'll remember that IP address because we'll try to correct that. Effectively, the traffic is attempting to egress one direction and then ingress another direction. And we'll talk about that next. So if we go into the HCX on-premise environment.
HCX, yeah, this one.
Yeah, okay, then I think I can verbalize, and Victor, I think you know where all the main areas are. So what we have to do is we have to update the HCX Mobility Optimized Networking policy. Effectively, what's happening in the background is that we're building a policy route into NSX, and that's all being driven by HCX. So HCX will make an API call into the NSX Manager and orchestrate this for us. And Victor, if we go to the Advanced tab at the top.
So Advanced Policy Routes.
And then this is where we put the policy routes to influence the egress traffic. So if we look at this, once it populates, by default, these will have all the RFC 1918 address spaces populated into the policy. So what does that mean? These are all the address spaces based on RFC 1918 that enterprises can use within their private addressing space, and they are not supposed to be routed out to the internet. So as a starting point, this is what we put into the policy. And if we match on these ranges, that effectively means, from an HCX perspective, send that traffic coming from the VM to the default gateway on premises. So across that layer 2 extension all the way back to the default router on premises. So what's happening here is that this VM is attempting, it was pinging from the VM in AVS to the VM in native Azure, but it was going back to on-premises. As Nahali showed in that diagram, it was tromboning back to on-prem. Then we just toggled on MON. These policies were applied by default. This is the starting point for the policies. So what's happening is we're trying to ping from that web VM to 172.16.1.5. We can see in the second line here, that's a match. And we can see that the state on the right is green. So if we match there, 172.16.0.0/12, that's a match because it's within that range. That means send those packets to the default gateway on premises. and then it goes to the default gateway on premises, and then it attempts to connect to the VM in native Azure. Although on the return path, that native Azure VM sees that /32 route that we showed before, that more specific host route, and it'll try to forward it directly to AVS across the Azure backbone. So now we have asymmetrical traffic. There probably is a firewall in between is blocking the traffic because that firewall does not see both legs of the flow. So in this policy route, we're going to attempt to tell it, please send that traffic that's egressing not to the default gateway on premises, but to the default gateway on the AVS side. Okay, so here we're running the ping, nothing's happening, so we'll try to correct that. So if you go to the policy route and we do an add, okay, perfect, and type in that address, so 172.6.1.5/32, and we're going to do a deny on that because we're trying to make sure it does not match the policy. Okay, so if we do a deny and add, we can see that now we have an option that says, okay, make sure that that traffic going to that destination does not do a match explicitly, and that will mean don't send it to the default gateway on premises, do it to the default gateway on the AVS side. And when we submit and try to open this again, it will change the order of these entries. This is not order specific. As long as we have that no match rule in there, it will send the traffic to the default gateway on the AVS side. So it's different than a firewall where you have to have it in a certain order. And now we can see the ping is working again.
Awesome. Yeah, this is the moment of truth. This is the key concept, right, Jeff, here. So Jeff, one question I have is, can you tell me that when you added the policy route, for example, just to kind of be on the visual side of the house, when we added the policy route, so before it was going this way, becoming asymmetric, the red flow, but where exactly did the policy route get added on tier 1 or tier 0?
Right, so HCX will orchestrate a policy route, which is a specific type of static route, into the tier 0. And it's a special type of static route because it not only looks at the destination to get to the next hop, it also needs to know what the source is and the destination to get to the next hop. So as Nahali mentioned, HCX applies a special policy route via NSX, and that gets applied to the tier 0. So now the question is, where the change that Nahali just made, where is that, if we had a problem, where can we look to find out where that's being affected? So if we go into the NSX environment and go into the tier 0 gateway.
On the AVS side?
That's correct. I think if we just open the arrow, Victor, and go to routing, and then IP prefix lists. Here we can see there's a special prefix list applied by HCX via an API call called prefix list for policy routes. And we can see there are 4 prefixes in there. So if you go to the 4 prefixes, this should match what we have in that policy built in HCX. It should be a 1-to-1 match. So we can see that deny that you applied, Nahali, has been applied here.
Got it. Perfect. Thank you, Jeff. So the /32 would still get advertised to Azure. Correct. But it will just make it symmetric. The return traffic. This is more for the return traffic.
That's correct.
Got it. Great stuff, Jeff. Thank you. Thank you, Victor. Jeff. Should we validate the rest of the flows? So the internet bound traffic should still go through on-prem. Maybe we just got a different.
What is 20? You know what I think actually, so there's a second part of this. In that policy, as long as it does a no match, it will go to the default gateway on the AVS side. There is no match for the quad 0 implicitly, not explicitly, but implicitly. There is no quad 0 defined. So it looked through all the RFC 19 address space. It says, I can't get to it. and it does not, it'll refer to the default route to get out, and that's not specified in the policy. So the default route should also use the AVS side because implicitly it does a no match in the policy. So that's why I think you're getting 20.x.y.z here. I think before you're getting like
40 dot something. Exactly.
Yeah.
So is this after the policy route? Because before we did the policy route and MON, just by the virtue of layer 2 extension, it was still going through the on-prem side.
That's correct.
But I see.
Now, if we change the policy to do a match on quad 0, the default route 0.0.0.0/0, and did a match on that, you should see that go back to the 40. We can try it.
Yeah, let's try it.
So now if we do an add and then do the quad 0/0, so 0.0.0.0/0, so that's your default route, and allow, and then add, that's fine, yeah. Now it's going to match, which means point that traffic to the default gateway on premises. Now let's see what happens. Might take a minute for the routing tables update. Let's see here. It might be ARPing. Try it again.
Nehali, Control C won't work for me.
Okay.
We might have asymmetrical routing again.
Now we broke it again. Yes.
Yeah,
so now let's think about it, right? So what's happening is we are here trying to reach the internet.
Yes, but you know what's happening is, so we're in a special case here because both AVS instances are on the Azure backbone. So we have asymmetrical routing. We're forcing that quad 0 traffic to go into the quote unquote on-premises AVS. It goes out, but then when it comes back in, because it still sees in that Azure backbone the /32 route, it's going to try to forward it to the cloud side. So effectively, we have, we have asymmetrical traffic and we're seeing what we saw before. But if we had on-premises, we would not have the same backbone. We'd have two different backbones and we could do this.
Got it.
We would not see that /32 route typically being advertised to on-premises. And that's something we could talk about during the presentation. But this is a good exercise.
Yes, definitely. And you would, in most cases, the desired behavior would be to kind of egress locally.
100%.
All right. And so now I think the last part is to just maybe migrate this web VM on this side and turn off this L2 segment. So a classic migration scenario would be we would bring everything from on-prem data center to Azure and then turn off the L2 extension, right? So
Victor, do you want to drive that one?
Yeah, so you want to do a migration, Holly?
Yes.
Of the virtual machine? All right, so let's
go. Should we do some ping running? Maybe let's go on one of the VMs that's getting migrated. So web VM, maybe go to the web.
So right here, the cool thing is like now that we have HCX plugin, we can go here and it says migrate to HCX target sites.
I see.
So we don't have to do it from the HCX portal. You can if you want to, but you have options.
Should we also launch, I was saying, the console or before you hit migrate?
Oh, sure.
Yeah, the web console. And here we could be pinging, maybe let's ping something in Azure just for.
Well, let's ping that VM. It's pure VM on the same layer too.
So ping 10.101.21.11. Oops.
Yeah. So right now we're pinging the VM on AVS across the layer 2 VPN. Now let's go ahead and migrate this VM. data store. The vMotion.
One thing should we fix that quad 0 route that we added? Just want to make sure that's maybe that
it won't break this, but yeah, we
Okay.
can fix that.
Because I thought that we could do a before and after test of Outbound as well, but
Yeah,
right now Outbound is broken from AVS Side, right?
Yes. Yeah. Let me just start the migration because that's going to take some time.
It takes some time.
Functional VMs, same sources format, and we're going to go ahead and validate it.
I don't think you chose the folder, Victor, but not the container above it.
Oh, thank you. Awesome. So that should start it. Then let's go ahead and fix pod. Dashboard, which see the migration.
I think, Victor, we lost your audio a little bit.
Oh, okay. Can you guys hear me now?
Yes.
Sorry, I was whispering. That's what I do when I can't speak and think at the same time.
Makes sense.
Here we go. HCX vMotion migration, right? 0%.
Yes. Okay, so while we wait, maybe we verify that your default route did fix our is fixed, and that so it's now again going back, and
Perfect.
so so then I think this one is still we didn't lose any no packet loss yet, and we'll see. Yeah, still going, right? Where were you looking? Here.
Yeah. Percentage.
Yeah. So once that's migrated, we would be able to use check the egress part, and then that would be what our last test, right? Or is there anything else, any validations?
We should see the ping milliseconds drop because right now we are at 2.23. I suspect it should drop to less than 1 millisecond.
Okay.
Oh, yeah, so there you go. So the console was disconnected because it's no longer on this host. So if we go to the vSphere environment on the cloud side, we should see
Web01 on-prem. Yeah.
Web01 on-prem. Open up the console. And sub-millisecond latency because we're no longer going across the backbone.
And we can see how it switched between 2+ milliseconds to 0 just above at the top. So Victor's right. We can see how that changes.
Yeah, awesome. Good test. If I control C, would we be able to see how many? So looks like it was seamless migration, really, right?
Yeah, pretty seamless. Typically, what customers do is once the VLAN or the layer 2 is evacuated, then you break the tunnel, you break the extension, and you tell HCX to migrate the gateway to the cloud side.
Oh, so we haven't yet disconnected the L2.
Yeah, so like
that's
for example,
last part.
That's the last part. So yeah, so for example, you wanted to ping a VM that's on the app network, it's still going across that layer 2.
Now, the one thing that maybe, Nahali, maybe you can also just verify, since we just migrated this machine, that is egressing to the internet on the AVS side.
Oh yeah,
with
good
your
point.
curl.
40 is, oh wait, so 40 is
Actually,
on
this is a
the
good
other
test.
side.
That's
Other side.
correct. That's correct. So we vMotioned this workload over, and by default, vMotion will not have MON enabled after the migration.
Ooh.
Only bulk migrations MON enable those VMs. vMotion migrations do not do that. You have to go back and enable that afterwards. So this is a good test. This indicates it goes back to on-prem. So if we go back into HCX, maybe Victor, if you're driving, we can look at that VM and see that even though it's on a MON-enabled layer 2 extension, the VMs that are attached that have been migrated, this one was vMotioned over, that VM probably is not MON enabled. Only workloads that are bulk migrated will automatically get that MON enablement after the migration has been done. So if we look here,
Yes, not MON is not enabled on that VM.
So
yeah,
instead
that's
of
correct.
doing it from here, then Victor, can we just switch over, like disable the segment for disable the L2 extension and switch the gateway, because we've already, that would be a good kind of thing to demonstrate. So maybe, but good call, Jeff. Yeah, that was expected behavior because it wasn't enabled.
Now, one thing that's going to be very different here, because we have an NSX environment.
Yeah.
So HCX talks to NSX. So right here it says connect cloud network, cloud edge gateway after unextending. And so basically what this is going to do is HCX on the cloud side is going to tell NSX, you're going to be the gateway now, right? So 10.101.21 is going to be enabled. What you have to do on premises is disable that network so it doesn't get advertised twice on the cloud
default
side.
gateway.
And yeah, exactly.
So is it a separate step or does it happen as part of this?
Well, in this case, Jeff, correct me if I'm wrong, it will be done automatically because we have NSX on both sides, if I'm not mistaken. But if you have, for example, a Cisco router,
Yes.
you're gonna have to do this yourself.
Yeah, let's try it. To be honest, I've never done cloud to cloud, but we can try that. If not, we'll just have the network advertised on both sides. We might have some strange behavior, which would indicate we have to disconnect the gateway on the quote unquote on-prem side. But Victor's right. This is really trying to orchestrate the entire process. It's going to leave the segment on the cloud side, on the right-hand side of the diagram that Nahali was sharing. It's going to unstretch that network layer 2 VPN and then leave that segment as is with the same name that I had originally on the on-prem side, but now on the AVS side, as if the entire migration is complete and you're unstretching all these networks. That's the correct behavior. Now we have a special scenario here where we have AVS acting kind of an on-prem, so we'll have to double check the behavior, but normally with on-premises, that would have to be manually disconnected, as Victor said.
And it, as part of this, it would automatically attach tier 1 on the AVS side. Yes.
Correct. Yeah. And obviously, I think it goes without saying that on-premises is partly going to be a VLAN. You want to make sure there's no physical VMs. Sorry, no physical servers on that VLAN as well.
Of course, before you evacuate, yeah, completely.
So now, if you do your curl, you should.
So the DNS, I wonder if the DNS is
That's right.
still
Because we didn't set up DNS on the. Yeah.
I bet you it's going on the. So did we have to set up the DNS here again?
Yeah,
right?
yeah, because we don't have a DNS server here because we were piggybacking up the DNS on the L2.
But 1.1.1.1 is the DNS server on the AVS side. That's Cloudflare. Can you do a quick ping test, Nahali? 172 or whatever you were pinging before.
Wait, which VM is this?
Are you the right one? Oh no, it's one on-prem.
Oh,
You're
we
supposed to be on
lost the.
on-prem. I think
Okay,
you're
so
going over, right?
So this is the AVS.
I think you're on web 01-on-prem, right? Yeah,
Yeah.
this one. Let's try this one.
So this one also lost because now they're both on this side, right? So it lost its IP and it
Oh, I
lost
see.
its
Okay.
DHCP now.
Mm-hmm.
Yeah, so we need to set up DHCP on this segment.
On the AVS side.
On the AVS side. Yeah.
Okay.
So that's a good point to point out, right? Like you want to make sure your stateful services are migrated before you do this process.
Mm-hmm. But wouldn't it be part of the segment? So isn't there is a local DHCP server already? So that means, so what would be the right order to do this then?
Yeah.
Because yeah, go ahead.
Where's the NSX side on in here?
Okay,
Your
sorry.
NSX.
Yeah, 1 second. I think okay, so this is the NSX side on the AVS side, and I would have expected it to pick up the local DHCP server here. So let's go to the.
It's called L2 Web, right?
Yeah.
Yeah, and I think the presumption is that DHCP on premises could be different things, not just NSX. So to orchestrate that would be kind of a challenge. You could have that as a third-party DHCP service.
What was the ranges again, Holly?
Sure, let me type that in. So this now becomes 101 web right 11.10 through 10.101.11. So in this case, we're keeping the IP as is, right? We're preserving the IP addresses.
Well, the DHCP server was on the other side, and because we broke the layer 2 tunnel, it no longer, the NSX server on prem is not acting as a DHCP server anymore. So we need to what we're doing right now is moving the DHCP server by configuring it on the cloud side.
Yeah,
and
to
this
that point,
should be fixed.
Yeah.
Sorry, go ahead.
Sorry, Nali. Yeah. So to the earlier comment, this normally would be something that the networking team would have a run book as part of the overall migration. HCX would assist in that migration, stretch, unstretch, connect gateway, although these are secondary services that would have to be coordinated. But that traditionally has been a separate run book for any kind of migration.
Yeah, makes total sense. Yeah, so like, so the DNS and DHCP would have to be orchestrated through runbook. And here the DNS server, Victor, was 10. Let me get it from our portal just to be safe. So this is ten 100.0192 is the AVS DNS server. So it will hand off the DNS along with the DHCP, right?
Yep. Go ahead and apply it. Subnet.
Does not belong to the subnet 21. Oops, sorry, that's my mistake. Web segment is 21. Web segment, yeah. Did it keep the DNS properly? Okay. Okay, awesome. So now we should get our IPs back. I'm not sure if we have to restart these, but I don't know how to.
Yeah, this is restart them. They're pretty quick to restart. Yeah, now you do your curl command. You should see it go from.
But now we are on the on-prem, the migrated VM. And now we go egress through AVS, the 2213. Of course, this one works as well.
And yeah, and you should also see those /32 routes no longer being advertised from the Azure side.
Yeah, that's a good point.
Mm-hmm. So let's. So this, we can refresh this. That doesn't exist anymore. Yeah. So this is good. Excellent. So Jeff, I think I was still thinking about your original point, right? Like this is almost like a DR, a full DR exercise, well, not just outbound, but even all of the inbound services like load balancing and all of those need to be orchestrated and planned out on the AVS side as well. It's almost like a full, yeah. With that, for completeness, let's look at the network topology as we see it in the NSX Manager. This is the on-prem side, the 577 at the top. This is the on-prem side, and this is what the final network topology looks like. Notice we have the DB on-prem and web on-prem and app on-prem segments. And on the other side, we have the extended segments, as you can see over here. The extended segments look like this. So this is the full architecture or the network topology, the way we see it on the AVS side with the extended L2 segments. So with that, Jeff and Victor, along with our AVS and networking GBBs, will be doing another more complex scenario presentation in part 2. So stay tuned for that. This ends our demo. Thank you, Victor and Jeff, for being available and showing us all the different scenarios. I appreciate your time, and we will see you in the next video. Thanks, everyone.
Thank you.
Great. Thank you, Nahali.